Hey kids, do let me know. Can you hear me? Can you see me? All my dear friends, everyone.
Decathlon Winter Collection.
Catch me howling
Yo,
at
Baba is over here. Welcome, welcome, Suswagatam. Finally, we got it. All my dear friends. Yes, how's the door? For this
Decathlon
chapter
60 plus
that is
sports
of
6000 plus
craft,
products. Visit the store or download the app.
Haloarenes. If I'm perfectly audible and visible, kids, then show me the green hearts for your Baba. If Baba
The green
is perfectly
hearts
audible and
for your
visible,
Baba. If
yes,
Baba, the
kids,
green
is
hearts
perfectly audible and
for your
visible.
Baba. If
Yes,
Baba, the
kids,
green
it's
hearts
perfectly
audible and for your Baba.
Just do
If
that.
Baba, the green hearts audible and for your Baba.
Just do
If
that.
Baba, the green hearts audible and for your Baba. If Baba,
I want
the
to
green
see
hearts audible
which
and
are
for your Baba.
really I have done a lot of really struggle for it. I want to see the green heart if I'm properly audible and visible. Now check. Now it's okay. Now check. Hello. Now check. Now check. आ जाइए आ जाइए। अब इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था।
With Monday.com, every business, no matter the industry or size, can simply work better. Monday.com adapts to every team's needs and connects departments in one unified workspace, giving the entire organization the ability to zoom out, track all moving parts, and make smarter decisions in real time. Go to Monday.com and start your free trial today.
होम रेमेडी या फिर इक्के तुक्के प्रोडक्ट्स से रीग्रोथ नहीं होता है। जैसे कि अगर मैं बायोटिन गमी खा लूँ या मैं एक हेयर फॉल शैम्पू खरीद लूँ, वो नहीं होता है।
अब इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था।
With Monday.com, every business, no matter the industry or size, can simply work better. Monday.com adapts to every team's needs and connects departments in one unified workspace, giving the entire organization the ability to zoom out, track all moving parts, and make smarter decisions in real time. Go to Monday.com and start your free trial today.
Now do let me know kids, is everything okay? Yeah, अब शायद सही होगा, because यहाँ भी green है वहाँ भी।
होम रेमेडी या फिर इक्के तुक्के प्रोडक्ट्स से रीग्रोथ नहीं होता है। जैसे कि अगर मैं बायोटिन गमी खा लूँ या मैं एक हेयर फॉल शैम्पू खरीद लूँ, वो नहीं होता है।
इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था।
With Monday.com, every business, no matter the industry or size, can simply work better. Monday.com adapts to every team's needs and connects departments in one unified workspace, giving the entire organization the ability to zoom out, track all moving parts, and make smarter decisions in real time. Go to Monday.com and start your free trial today.
Now do let me know kids, is everything okay? Yeah, अब शायद yes kids, because यहाँ भी green है वहाँ भी।
होम रेमेडी या फिर इक्के तुक्के प्रोडक्ट्स से रीग्रोथ नहीं होता है। जैसे कि अगर मैं बायोटिन गमी खा लूँ या मैं एक हेयर फॉल शैम्पू खरीद लूँ, वो नहीं होता है।
इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था।
With Monday.com, every business, no matter the industry or size, can simply work better. Monday.com adapts to every team's needs and connects departments in one unified workspace, giving the entire organization the ability to zoom out, track all moving parts, and make smarter decisions in real time. Go to Monday.com and start your free trial today.
Now do let me know kids, is everything okay? Yeah, अब शायद yes kids, because यहाँ भी green है वहाँ भी।
होम रेमेडी या फिर इक्के तुक्के प्रोडक्ट्स से रीग्रोथ नहीं होता है। जैसे कि अगर मैं बायोटिन गमी खा लूँ या मैं एक हेयर फॉल शैम्पू खरीद लूँ, वो नहीं होता है।
इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था।
With Monday.com, every business, no matter the industry or size, can simply work better. Monday.com adapts to every team's needs and connects departments in one unified workspace, giving the entire organization the ability to zoom out, track all moving parts, and make smarter decisions in real time. Go to Monday.com and start your free trial today.
Now do let me know kids, is everything okay? Yes kids, because यहाँ भी green है वहाँ भी।
होम रेमेडी या फिर इक्के तुक्के प्रोडक्ट्स से रीग्रोथ नहीं होता है। जैसे कि अगर मैं बायोटिन गमी खा लूँ या मैं एक हेयर फॉल शैम्पू खरीद लूँ, वो नहीं होता है।
इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था।
Monday.com, every business, no matter the industry or size, can simply work better. Monday.com adapts to every team's needs and connects departments in one unified workspace, giving the entire organization the ability to zoom out, track all moving parts, and make smarter decisions in real time. Go to Monday.com and start your free trial today.
Now do let me know kids, is everything okay? Yes kids, because यहाँ भी green है वहाँ भी।
जैसे कि अगर मैं बायोटिन गमी खा लूँ या मैं एक हेयर फॉल शैम्पू खरीद लूँ, वो नहीं होता है।
इसमें पहले आप वहाँ से चेक कर लीजिए, ये सब माइक का वही है जो जैसा था। Now do let me know kids, is everything okay? Yes, because यहाँ भी green है वहाँ भी।
जैसे कि अगर मैं बायोटिन गमी खा लूँ
आपकी आवाज रुकी है। हेलो 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 हे एवरीवन, आ रही है? दिखा रहा, आवाज़ तेज करना। हेलो हेलो, हाँ everyone, do let me know now. Check please if everything is clear. Now if it is clear, yeah, we got the success, kids. Finally, really, I was thinking, kids, that really it required too much time, but finally I think everyone show me the green hearts, kids. If yes, everyone can hear me, can see me, and call everyone that yes, I want to see green hearts, kids. because messages I cannot read, but yes, I can see the green hearts. Yes, kids. Yes, 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 kids. Green or red or whatever the hearts you can show. Kids, really, really thanks for your kind support. Without your support, it was not possible at all. Now, kids, in every group, write it down that yes, we are the winner. Ultimately, efforts are working. Ultimately, efforts are working, and we got it. We got it. Finally, we got it. Wow, kids, it's a time to yes, say yes. I want to see fire. If the Josh is really high, everyone, I want to see Josh in the chat section in the form of fire, kids. Yes, yes, yes. Baba want to see the fire in the chat section. Yes, now I can see everyone is there. And we can start it. We can start it with full on Josh. Yes, kids. Yeah, here is your chapter, Haloalkanes and Haloarenes. This is given in class 12th. Yes, second part. Now, what I want to say that in this chapter, SN1, SN2, E1, E2, I will take each and everything, whatever is required, and this chapter really holds a hell lot of weightage. And Baba is going to tell you, your HSP Baba is going to tell you each and everything. Yes, that's really awesome. Finally, we are here.
Have you still not joined our 6 days reading challenge? We noticed you've been checking out our ads, and if you could not join due to other commitments, we totally understand. Don't worry, we still have few slots available.
Yes.
Totally understand. Don't worry, we still have few slots available.
Yes.
Totally understand. Don't worry, we still have few slots available.
Yes.
Totally understand. Don't worry, we still have few slots available. Totally understand. Don't worry, we still have few slots available. Totally understand. Don't worry, we still have few slots available. Totally understand. Don't worry, we still have few slots available.
My passion. So, my dear friends, if you're new to this channel, this is your channel only. Subscribe it and smash the like button. Now, I'm going to start with each and every hello everyone, last part, and so let's start from the script that everyone in I hope that everyone is ready. So, this chapter, the most important thing is how to find out once I will see the trick, and then I will let you know my discipline. What is trick? And then so I hope that everyone is ready. So how many of you are interested in the trick? If you are interested in the trick, I want to say if you are interested in the signal, because signal means a lot. Signal means a lot. If everyone is ready for the trick, then
क्या चल रहा है?
प्रैक्टिस मेरी संगीत की।
वाह मिस नौटंकी, कोई मिले तो पहले।
मिसेस नौटंकी डैड, आप बस करो मेरी शादी की तैयारी,
क्योंकि अब है गारंटी हमारी शादी.com। रजिस्टर नाउ।
in fraction of seconds, you will be able to understand whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, SN1, E1, E2. My dear students, whether the reaction is SN2, क्या है? हाँ, हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। अब ये ऊपर वाला भी मूव करना चाहिए, ऊपर वाला मूव करना चाहिए था। ये क्या है? हाँ, हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। अब ये ऊपर वाला भी मूव करना चाहिए। हाँ, आवाज सही है, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हाँ, हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। अब ये ऊपर वाला भी मूव करना चाहिए। हाँ, आवाज सही है, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हाँ, हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। अब ये ऊपर वाला भी मूव करना चाहिए। हाँ, आवाज सही है, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। अब ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। अब ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 हेलो। अभी ग्रीन तो हुआ था अभी। ये ऊपर वाला भी मूव करना चाहिए। आवाज सही, ऊपर वाला मूव करना चाहिए था, फिर गड़बड़ हो गई। ये क्या है? हेलो 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 not going, it's echoing. Echo is there, it's flickering, yeah, I don't know, they have tried everything. Hey everyone, can you hear me now? Kids, now finally, do let me know. Everyone, am I perfectly audible and visible to all of you? Now just check. Hello, hello, check, check, check. Everyone, do let me know if yes. Show me the green signal. I want to see green signal, kids. Hello, hello. Voice check. Yeah, now it's fantastic. I can see. Kids, sorry for the interruption. Now, tell everyone, now the voice is absolutely clear. Fit and fine, kids. Perfectly clear. I can see, kids. Let me check it out. Yes, call everyone. Tell everyone that yes, Baba is here. Yes, 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 kids. So let me send the message that everyone, just give me a second, kids. Tell everyone, kids, send the message. Let me send the message in the groups so that everyone should know that everything is perfect now. Now, should we start? Should we start? Is everyone fit and fine? If the Josh is high, after all, we got the victory in this. That finally, yes, it's perfect. And now Baba is going to start with this trick, magical trick. So call everyone so that we can start with this SN2, SN1, E1, E2. I will tell you one simple story, kids. With simple story, Baba is going to tell you a very simple scientific story. Simple and scientific story. Baba is going to tell you simple scientific story without any knowledge, without any knowledge, without applying brain, without applying brain. Baba is going to tell you SN1, SN2, E1, E2, how to find out SN1, SN2 just within second. Is it possible, kids? Do let me know. Is it possible that anyone can tell you? Is there anyone who can let you know that how to find out SN1 and SN2 without teaching? Without teaching. Baba is going to prove this without teaching. Without teaching. And definitely I will let you know how to find out whether the reaction is SN1 SN2, E1, E2 without teaching? Is it possible, kids, that a teacher can let you know that immediately by simply seeing the reaction, what type of reaction the compound is going to show, whether it is SN1, SN2, E1, E2? But yes, Baba's trick, Baba's magic, that simple story Baba is going to tell you. Okay, so everyone is there. Is everyone ready? If yes, I want to see some fire. Show me the fire if yes for this SN1, SN2, E1, E2. Just simply seeing the reaction, if you are going to find out what type of reaction it is. Baba want to see the fire in the chat section. That if you are ready, kids. Yes, everyone is ready. Now see, kids. Let me take the thing that is known as, there are three type of patients. These are the patients. That is RX. Three types of patients. Patient number 1, methyl halide. This is the patient number 1. Its name is methyl halide. Second patient is isopropyl halide, CH3, isopropyl halide. And the third type of patient is CH3, CH3X. Okay, these are the three types of patients. Patient number 1 is having 1 degree. This patient is having 1 degree. This name is methyl halide and it is 1 degree. This halogen is attached to the carbon. This is patient number 2. It is having 2 degree because 2 degree alkyl halide, and this carbon is attached to 3 carbons, 3 degree. Three types of patients we are having. And we are having 4 types of doctors. Let me tell you, doctor number 1, doctor number 2, doctor number 3. These nucleophiles oblique base, or let me tell you type of reaction. These are type of reaction. So kids, what I am telling you, these are the 3 types of patients and 4 types of doctors. Doctors' name are like SN2. Second doctor is E2. Third doctor is SN1. And this is E1. The fundamental thing is that these 2 doctors, they are doing operation just in seconds. Means they are not taking too much time. Within fraction of seconds, they are doing the surgery. Okay, they are going to do surgery within fraction of seconds. Single step reaction. And these are making that operation complex. Multi-step reaction. Now kids, let me tell you that this patient want to undergo operation with this doctor, and even this doctor wants to do the operation of this patient. Rest of other, they want to do treatment. Yes, their likings are like this. Means if I say that this arrow toward this side, this arrow also toward this side, and this arrow also towards this side. This patient wants to get treatment from these 3 doctors, or these 3 doctors are going to treat this patient. Just see the arrows first. Everyone just see the arrows first. Have you seen the arrows? Do let me know. Show me some hearts if you have seen the arrows. That this patient wants to get treatment from these doctors, and this patient wants to get treatment from these doctors. Now this patient doesn't want any treatment, so its liking is like this. So it is saying okay, 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 okay. So this patient wants negligible treatment from all these doctors, but the liking is equal liking. So see, my dear students, can you see everyone? First of all, do let me know that methyl halide wants to undergo treatment with SN2. Tertiary alkyl halide wants to undergo treatment with all these doctors, and this is having negligible liking but liking with all four. If these arrows are clear to all of you, then Baba is going to tell you each and everything within fraction of seconds. Just to let me know if this much is clear, show me the thumbs up. If this much is clear, these arrows are clear, then show me thumbs up in the chat section. Baba want to see the thumbs up. Then within fraction of seconds you are going to solve any question. Yes. Now see, in this movie, director suggested no one can get treatment from more than 2 doctors. Maximum 2 doctors are going to treat you. No patient is allowed to get the treatment with more than 2 doctors. No patient is allowed. No patient is allowed. Okay, no patient is allowed. So who is going to decide? If the patient is not able to decide, then their decision will be given by the main doctor. Main doctor is type of nucleophile oblique base. This is the headmaster, head doctor. These are of 2 types. One is strong, another one is poor or weak. Poor or weak. How to find out which one is strong, which one is poor or weak? Let me tell you, if it is having negative charge, RO negative like RONA, it can be written like RONA, or it can be written like ROK. And how to decide it is poor or weak? Poor is ROH and weak is water. Okay, if this much is clear, then let me tell you, this doctor, these 2 doctors were saying I will do any operation in single step. So this strong head doctor is supporting these two, remember that this head doctor is supporting these 2, and this poor weak, because they are saying that operation should be continued very slowly. So these are supporting these doctors, right? Is it clear? Poor or weak are saying then operation should be continued slowly and steady by taking care and thinking of stability, but the strong doctor is saying the operation should be in single step. If this much is clear, first of all, do let me know any doubt, any problem till here. If everything is clear, then only Baba is going to tell you, kids. Then I will show you the magic, how the magic and what's the magic is there. Kids, I will show you the magic. Is everyone ready? If yes, show me the green hearts, red hearts, whatever the fire or anything in the chat section. If this story is clear to you, just take the screenshot of it. You can take the screenshot of it. Then I will show you the magic. And then I will tell you all these reactions in detail, kids, detail. Yeah, now see, once again, let me tell you, these are 3 patients. This patient's name is methyl halide. This patient's name is methyl halide. This patient wants to get the treatment from SN2. This is secondary alkyl halide. Its name is isopropyl halide. Now this requires treatment from all 4 doctors, but it is not in need of. It is saying, no, I don't want to undergo surgery. And this is tertiary alkyl halide. And it is saying, okay, I want to get treatment from all 3. But main head doctor said, no one is allowed to get treatment with more than 2 doctors. Then let's see, and the value of X cannot be fluorine. The X cannot be fluorine, X can be chlorine, bromine, iodine. Now let's see. If I say find out the type of reactions, find out type of reaction, find out type of reactions. First reaction is given like this: CH3, CH, Cl, CH3. Just find out what type of patient it is. This patient is 1 degree, 2 degree, 3 degree. Write down in the chat section. This patient is 1 degree, 2 degree or 3 degree. What is the degree of this patient? Everyone write down in the chat section. Then only you can understand. Everyone, 2 degree. Very good. This patient is being 2 degree. This patient wants to get treatment with whom? This patient wants to get treatment from whom? With all the 4 doctors. With all the 4 doctors, that is SN2, E2, SN1, E1, right? But there was one twist in the story, that no patient is allowed to get the treatment with more than 2 doctors. Then see, the head one is C2H5ONA. This is strong or weak? You will say this is going to be strong. So strong will say you have to take the treatment with whom? Let me show you, kids. Let me show you. See, the strong will say you should get treatment with whom? You should get treatment with whom? SN2 and E2. The patient was saying, I want to get the treatment with all these 4. But this head strong one said, you have to get treatment with whom? You have to get treatment with the strong one, because I'm being strong. So the suggestion is with the strong. So what type of reaction it will undergo? Just do let me know. Yes, SN2 as well as E2. What you are able to understand, kids, that 2 degree alkyl halide, when it is going to react with a strong entity, it will undergo substitution as well as elimination simultaneously. Simultaneous what, kids? Simultaneous substitution as well as elimination, and that is in single step reaction. 2 is indicating, 2 means single step reaction. No intermediate will get formed, no ring expansion, no hydride shift, no methyl shift. I will let you know each and everything, but kids, this 2 is indicating single step reaction. And single step reaction means what? Single step reaction, kids. Just a second, kids. This is indicating single step reaction, and single step reaction means what? No intermediate formation. No intermediate formation means no ring expansion, no rearrangement. Kids, this is clear to Each and everyone, do let me know. Is it clear to each and every one of you? First of all, do let me know, kids. I want to see in the chat section that this is clear to each and every one of you. I want to see green hearts, kids. Connectivity is the most important thing. See, my voice was, I was not audible properly, so there was the problem. But if I'm not able to see that whether you are able to understand, then that is going to be a problem. Kids, I want to see in the chat section that everyone is able to understand. Very good, very good. Now see, this was secondary alkyl halide. Secondary alkyl halide. Now, if I give you another question like this, question number 2, that the same alkyl halide CH3, CHBr, CH3, its name is isopropyl halide, isopropyl bromide. Now this time this is reacting with C2H5OH. Now do let me know what type of reaction it will undergo. I'm not going to help you at all. Baba is not going to help you at all. And Baba is just trying to see in the chat section whether my kids, whether the HSP and army is able to solve this question or not. Baba is just watching the chat section. Let's see how many of you can give the correct answer, kids. How many of you? Yes, yes, yes. Some are giving the correct answer. Some are going to give the wrong answer. Just see. You see this chart. This will change your life. This will make you the best rank holder. Just see, this is 2-degree alkyl halide. It was liking all 4 doctors. But all 4 doctors cannot do the treatment. Then if any patient is liking all 4 doctors, then who is going to decide? This headmaster is going to decide, and headmaster is ROH. ROH means ethyl alcohol. C2H5OH is weak. This is weak or poor. Weak or poor is supporting SN1 even. Now tell me what should be your answer, kids. If you are really able to understand, do let me know what should be your answer. Everyone, Baba is going to tell you the most important thing. No one is able to understand this thing. Kids, do let me know. What's your answer? Yes, answer is absolutely correct. Absolutely correct. Answer is SN1 and even both. SN1 and even both. That means this reaction will undergo simultaneous substitution plus elimination. That means both two things will undergo simultaneously. And one means what? One is indicating complex reaction. Complex reaction, and complex reaction means what? More than one step means more than one step. And more than one step means what? More than one step means, kids, intermediate formation will be there. Intermediate formation. And whenever there is intermediate formation, my dear students, rearrangement may take place. Rearrangement may take place. So these are very, very important things. Once again, is it clear to each and everyone? Keep on showing hearts, fire emojis if things are getting cleared. Kids, let me have a sip of water for complete 1 hour or more than 1 hour. I have tried for the perfect voice. Now, kids, now see the real magic. You have seen 2 slides. This was 2-degree alkylate and this was strong nucleophile oblique base. Then you have seen this was 2-degree alkylate and this was weak base. Weak base. What is common? What is being common? What is being common? See, here also substitution as well as elimination it was undergoing. Here also substitution as well as elimination it is undergoing. So 2-degree alkyl halide. 2-degree alkyl halide will always undergo substitution as well as elimination, whether this attacking agent is weak or the attacking agent is being strong. Whether the attacking agent is strong or weak or poor, 2-degree alkyl halide will always undergo substitution as well as elimination. What is that? That means whenever I'm going to put heading substitution, I will teach over there substitution only, and whenever I'm going to put heading elimination, I will teach over there elimination only, and I will write down the product of elimination, and whenever I'm teaching the substitution, I will write down the product of substitution. Now, if the kids are not aware of this chart, memory chart, mind map, then they will see that in substitution, in their memory, substitution will be there. In your memory, whenever elimination I am going to teach, elimination will be there. But the examiner will ask each and everything. Then kids will not be able to understand whether the reaction is giving both substitution as well as elimination. And that's why this memory chart is going to help you a lot, because this is going to give you a wide view. Overall view will be better. Kids, are you able to understand? Now see, let me write down the most important thing. Secondary alkyl halides, will undergo substitution as well as elimination. What I'm saying? Secondary alkyl halides will undergo substitution as well as elimination, whether the attacking agent is strong, whether the attacking agent is being strong, weak, or poor. Is this point clear? I hope this point is very, very clear to all of you. Very, very important point. Very, very important point. It depends whether it will follow single step reaction or it will follow more than single step reaction. It all depends on the type of that attacking agent. I hope that this is clear to all of you. Now, question number 3. Just see. Question number 3, everyone. Now, this time don't give wrong answer. Question number 3. If I write down like this, CH3, Br, CH3, people call it tertiary butyl bromide, tertiary butyl bromide. Now, if in front of this, it is written like C2H5ONA, no speed. I don't want to see speed. Just try to find out what is the degree of this alkyl halide. Just try to find out what is this attacking entity. Then only give the answer, kids. It is going to be the game changer. Let me check it out in the chat section what you are going to write. Oh my God, Muhammad, Medico, Madhu, everyone. Yes, kids, you're rocking. Yes, you got this story. You got this story that only E2 only, kids, only E2. Only E2. That's really fantastic. Something fantastic. Only elimination, no substitution. And for this, Williamson's got Nobel Prize. For this thing, Williamson's got Nobel Prize. He said, let me tell you one thing, that whenever you are going to do with substitution, you are getting ether. I will let you know how. Substitution gives ether and elimination gives generally alkene. So what Williamson said, let me first enclose it in the box, that whether if I say whether we are going to deal with SN2 or SN1, we are going to get ether, or whether we are going to deal with E2, E1, we will get alkene. So Williamson said, if you want to prepare ether, never take 3-degree alkyl halide. You must remember this. And those who have given last year the paper, those who have written NEET paper or IIT paper, they would be having this thing in their mind that 3-degree alkyl halides are not going to give ether, only E2, that means only alkene. It will give only alkene and no ether, no ether, no ether. And this is the very, very important point, very, very important point. Everyone got it? I hope that this is clear to each and everyone. Yes? Now, let me show you the question number 4. Question number 4, my dear students. If you are having compound like this, CH3, CH3, Cl, CH3, this is also tertiary butyl chloride, and suppose the examiner has written C2H5OH. Now let me check it out. This time what you are going to say, this is ethyl alcohol. Now let me see in the chat section what answer you are going to give, kids. Let me check it out. Oh, fantastic. Absolutely correct, kids. Absolutely, your answer is 100% correct, 100%, 101% correct, kids. Really awesome. It is SN1, E1. SN1 and E1. Fantastic. Fantastic. The memory chart, the magic is working. Now see, question number 5. Question number 5, kids. If question is given like CH3 Cl plus C2H5ONA. Now let's see who is going to give the correct answer. Methyl chloride, sodium ethoxide, sodium ethoxide, sodium ethoxide. Let me check it out. The answer in the chat section. What you are going to write, kids? Let me check it out. Only SN2. Fantastic, fantastic, fantastic. Only SN2 means only substitution, only ether formation, only ether formation. And only ether formation means this is the best technique. Williamson said this is the best way. Williamson's synthesis of ether. This is the Williamson synthesis of ether to get the best yield of ether. Best yield of ether because there is no elimination. No elimination, only substitution. No elimination, only substitution. Only substitution. I hope, dear students, if this is clear to each and everyone, then I'm going to tell you the detailed mechanism of all these things, SN1, SN2, why the elimination is happening, why the substitution is happening. Number of kids must be thinking, sir, for the elimination temperature is required, then how without temperature you are going to do this? My dear students, whenever the temperature is given, that is the clear-cut indication of elimination. But when the temperature is not given, then only genius can do such type of questions. No, not everyone is able to do such type of questions. I want to see that everyone is ready. How is the Josh, kids? Baba want to see the Josh. Your Josh is high, or you got tired? Everyone do let me know. Yes. Now I'm going to start from the beginning. If this story and the memory chart is clear to all of you, then do let me know. Then only I'm going to tell you in detail. Then Baba is going to tell you in detail. Kids? Yes. Now see, from the beginning, what is base? Difference between base, difference in between base and nucleophile. Difference in between base and nucleophile. Just see, kids. Base deals with chemical equilibrium, deals with chemical equilibrium. Now something is having negative charge that will accept proton, will react with proton, or will snatch proton, will react with proton or will snatch proton, and this will become base and hydrogen will be with this. It's like this. So how much equilibrium can go in the forward direction, that is indicating the base or the basic strength. But if we want to deal with nucleophilicity, kids, nucleophilicity deals with chemical kinetics, deals with chemical kinetics. Now chemical kinetics means the speed by which by which any entity can form a bond, with carbon, Now kids, it doesn't deal whether the bond is stable or unstable. Nothing about stable. It can be stable or unstable, can be stable or unstable. The bond can be stable or unstable, but it deals with the speed. I hope this much is clear to all of you. Now see what I'm going to tell you. See, just see. If I say that I have taken this compound CH3, CHCl, CH3. Now see the interesting thing, very, very interesting thing. This is C2H5ONA. Now two types of entities are there. This is pure organic. That means this is your substrate, because its carbon is going to form the bond. It is going to involve in the bond formation. This is delta negative. This is the polar bond. And here you can see this is ionic bond, Just do let me know, my dear friends. If I ask you one question, out of these two entities, two persons, two types of persons are traveling, they are having a journey in the train. So they will see, they will smile, and this will say, oh, I can't tolerate, I can't sit, keep quiet, I can't be mum. I have to start because this is ionic bond. And see, this whole is known as reagent. This whole is known as reagent. Let me show you. Let me show you. When you buy when you buy banana from the market, this is in this form. Now, can you eat banana like this? No. This banana is available in the market in this form only because it is stable. But if you want to eat it, you have to peel it. Now, what you will do, you will separate that portion and you will eat this part, and this part is the attacking agent. You will eat it. So, that means this is the reagent, but this is not the attacking part. It will break. It will break into these two parts. And this part is known as attacking agent. This part is known as attacking agent. This part is attacking agent. This was the reagent. This part is attacking agent. Only this part. That part is not attacking agent. This part is attacking agent. And it is having negative charge. It is having negative charge. If you are preparing for medical, what you want? You are hungry for the seat. The one who is giving IIT, that person is hungry for the IIT seat. But this negative charge is in need of what? This is in need of either it should get carbon positive, then it will get neutralized, or it should get proton, then it will get neutralized. Now, if I say it is reacting with carbon, then people will say you have played the role of nucleophile. And if it is reacting with proton, people will say you have played the role of base. Role of base, role of nucleophile. But it will play all the roles because number of molecules, infinite molecules of this compound will be there. This compound's infinite molecules will be there. This compound's infinite molecules will be there. Some must be acting as base, some must be playing the role of nucleophile. You must have seen that people gathered during marriage, parties, get together. Then what they are doing? They will take the plate. Some of them will take rice, paneer, salad, and they will start eating. Some others will take dosa, idli, sambar, and they will start eating. Some others will start from the last. They will take ice cream. Not every person is doing the same thing. They are just hungry. They are having something to eat. They are starving. They are wanting to have something to eat. Are you able to understand what Baba is saying? Not all the molecules will do the same thing. Some will be reacting with this. Some will be reacting with this. And let me tell you, my dear students, if this C2H5O negative is accepting proton, people will say you have played the role of, yes, everyone say played the role of what? Role of base. And you will be responsible for giving elimination reaction. It will give elimination reaction, my dear students, elimination reaction. And if the same C2H5O negative is reacting with carbon positive or partially positively charged, people will say played the role of what? Played the role of what? Role of nucleophile. Then people will say you will be responsible for substitution reaction. But the molecule, same molecule, is in double role. It is playing both the two roles. Double role. It is in double role. Now, if this point is clear, then I can move ahead. Till now it is clear. If till now it is clear, I want to see some fire in the chat section that yes, sir, it is clear, because I cannot read out the chat. I can just see the emojis, the green signal, the blue signal, whatever the symbols you can send me. Just I want to see. Yes, kids. Till now it is clear to all of you. Baba wants to know that yes, it's clear. Now see, what I'm telling you, that this compound CH3, CHCl, CH3 is reacting with C2H5ONa, and it is responsible for two types of reaction, SN2 and E2 both. That means, let me divide these two reactions in two halves. First half, let me say SN2. Second half, let me say E2, and combine together complete reaction. Combine together complete reaction. Let me first explain first half, then second half, then you will come to know the complete reaction. Because if I am going to tell you simultaneously both the two halves, you won't be able to understand. Just like in your electrochemistry chapter, you must have seen what? That teacher must have told you oxidation half first, then reduction half first, then he must have combined, your teacher must have combined together to give the complete net cell reaction. So everyone is ready? Now see, first half SN2, second half E2. I'm going to tell you both the two halves. So let's see what we are going to see. See, first half is SN2. Just see to it. This is your molecule CH3, CH, Cl, CH3, and this was your C2H5ONa. Now kids, I'm just right now trying to tell you the difference in between elimination and substitution. When I'm going to tell you SN2 in detail, I will let you know each and everything. But right now I'm going to tell you these two halves. Just see, this Na plus will take this Cl negative. So the Cl negative has gone, it has developed positive charge. So the C2H5O negative will come and take its proton. Once it is going to take its proton, how it will take? It will say you are having two hydrogen, one hydrogen, just give me one hydrogen in the form of proton, and you keep your electron with you. You just keep your electron with you. So I will go like this. I will go like this, and you will get negative charge. Now negative and positive will form a bond. So see what you are going to see. CH3, CH, double bond CH2 you got, and you got Na, C2H5OH, C2. Okay, substitution. Sorry, I was going to show you the substitution. I have done elimination, kids. I have done elimination. Just see to it. This will take NaCl because I was going to tell you about substitution. Okay, so the C2H5O negative will attack on carbon. Okay, kids. Sorry for that. I screwed up. I was about to tell you first substitution. I have started telling you elimination because elimination will also take place. So how many products you got? You got two products. One is CH3, OC2H5 plus NaCl. Is it clear? Now, two types of reactant, two types of molecules reacted together to give two types of products. Two types of products. Now, if you see the thermodynamics of this reaction, if I talk about thermodynamics of this reaction, that two types of molecules got two types of product. Delta S is approximately 0. I will not say 0 because delta S depends on number of things, rotational energy, translated number of energies, but approximately it is 0. Now see delta H, weaker bond has broken up. Why weaker bond? Why it is weaker? 2p and this is 3p, and that's why I have told you this X cannot be equal to fluorine. It should not be fluorine. 2p was bonded with 3p, bond was weaker, but here 2p and 2p bond is being stronger. To break the weaker bond, less amount of energy will be required, and whenever this bond is formed, large amount of energy will get released. Let me make it clear. Whenever you want to break a bond, energy is always required, and whenever the bond is formed, energy will always get released. So suppose if I have given 100 joule energy to break this bond, which bond? This bond, and 200 joule energy has been released. So final minus initial, you know that energy released is always delta H is negative. So delta H will come out to be negative, and reaction is being exothermic. Till now it is clear or not? This thermodynamic fundamental thing is clear to each and every one. Kids, do let me know. Is this point clear to each and every one of you or not? Do let me know. Is this point, thermodynamic point, is clear to each and every one of you kids? Now, for substitution reaction, if anyone is going to ask, low temperature is good, favorable for this reaction, or the high temperature is favorable, do let me know. If you are able to understand, my dear students, do let me know. For this reaction, high temperature is favorable or low temperature is favorable. Do let me know in the chat box. Low temperature, I can see Madhu's answer. Low temperature is favorable for such type of reaction. That's really awesome, kids. Low temperature is good for, low temperature is good for substitution. Point to be noted, my lord. Low temperature is good for substitution because exothermic reactions require low temperature to give better yield. Now see the second half. Baba is going to tell you second half. Second half. This was your reactant CH3, CH, CH2H, CHCl, and in front of this there was C2H5ONA. Now see to it. It was like this, negative, positive. Now see, this Cl will go along with Na plus. It will develop partial positive charge. Now NaCl has gone partial positive. Now this C2H5 negative will take its proton. Now it will develop, it is having plus charge, plus minus, and this is negative. Now see, three reactions at a time. Three reactions are taking place at a time. This has got converted into CH3, CH double bond CH2. That has got converted into ethyl alcohol C2H5OH, and this got converted into NaCl. Now this time you can see two types of molecules, reactant side, two types of molecules have been converted into three types of products. Can you see? Now, my dear students, if you talk about thermodynamics, the change in entropy delta S, final is more, three types, initial less. So 3 minus 2 is how much? Positive. For this reaction, change in entropy is positive. That means entropy disorder is getting increased or decreased. So 100% disorder is getting increased. Disorder or randomness is increased. Randomness is increasing. Now see how many sigma bonds are getting broken up. One sigma bond is getting broken up. Second sigma bond, no, this is not getting broken up, but this sigma bond is getting broken up. Two sigma bonds are getting broken up, and in place of that, one pi bond has been formed. To break two sigma bonds, more amount of energy will be required, and to form pi bond, released energy will be less. So required is more, released is less. So if I talk about delta H for this reaction, that will come out negative or positive? Positive. So who is the driving force for this reaction? If I talk about Gibbs-Helmholtz equation, delta G equal to delta H minus T delta S. So definitely this is positive. It is saying not feasible reaction. Not feasible. So the driving force is delta S, and for delta S, temperature should be high to get this magnitude more, and that's why high temperature is favorable or low temperature is favorable. Definitely high temperature is good for elimination. This point is clear. If everyone got the logic, show me some fire in the chat section. Let me see that kids are able to understand or not, my dear students. All NEET Endgame students are there. NEET Endgame 1, NEET Endgame 2 students. Avengers are there. Is Avenger people are there. All NEET English batch are there. First half. Ramesh is asking, Baba explain first half. Kids, if it is clear to all of you till now, show me the hearts. If not clear, kids, your communication, your connectivity with Baba means a lot. Baba want to see that everyone is able to understand. Baba's writing is clear to all of you. Baba's representation is clear to all of you. If everything is clear to all of you, my dear students, Baba is in front of you. If everything is clear, then show me the green hearts. Now, kids, all these things are taking parallel simultaneously. Session duration, don't ask. Okay, Ramesh Kumar, writing is perfect. Session duration, please don't ask about the Baba. High temperature means how much? High temperature means more than room temperature. High temperature means heating more than room temperature. Anything can be high as compared to other. High temperature just means more than room temperature. Okay, now see kids. Now, before moving ahead, Baba wants to tell you that Baba is going to start substitution reaction in detail, because simultaneously I cannot tell you substitution and elimination. I have to tell you substitution and elimination separately. So Baba is taking permission. Okay, one more thing. If you have not studied chemical kinetics, first let me know, have you studied in chemical kinetics what is the first order reaction and second order reaction? If you have not studied, then Baba let you know first what is the meaning of 1 and what is the meaning of 2. Then only Baba can start. What is the meaning of SN1 and SN2? Then only we are going to get benefited. First of all, do let me know. So, how many of you want to understand what is the meaning of SN1, SN2? Then Baba explain first half. Okay. Okay. First half. Let me tell you the first half. Just see. This was the reactant. that was the attacking agent. This Na has taken this chloride. NaCl has gone. Once NaCl has gone, this O negative is attacking on this carbon. This O negative is forming bond with this carbon. That means this is acting as a nucleophile and it is attacking on this carbon. So this O has formed with this carbon. O has formed bond with this carbon and NaCl has eliminated out. So one type of molecule, two types of molecules reacted and they have produced two types of products. These two gone, new two formed. So change in entropy is 2 minus 2, how much? 2 minus 2, 0, approximately 0. Now sigma bond is breaking and sigma bond is getting formed, but this carbon belongs to second period and chlorine belongs to third period, but oxygen and carbon both belongs to second period and second period. This bond is being strong bond. That bond was weak bond. Weak bond has gone broken up, strong bond is formed. So less energy is required to break the bond, more energy has been released. So required is less. Suppose if I say required I will say delta H is 100 joule. Now released is more. I will say for this formation delta H is minus 200 joule. Now final minus initial, if I say delta H for this reaction is final is minus 200, final minus initial. So either I can say required release, if I leave the magnitude, then also you can see overall released is more, required is less. So overall this is going to come negative only. Kids, you got it? Those who were unable to understand, do let me know. You got it or not, kids? Do let me know. Those who were unable to understand the first half, do let me know, kids. Those who were unable to understand. Chandar, Darshani, why you are leaving? Chandar, Darshani, what happened to you? I want to see. Chandar, Darshani, what happened to you? Why you want to leave? I can't understand. Chandar, Darshani. Okay, now see, kids. Now see, everyone. Baba is going to start with SN2 reaction. Is everyone ready? Baba is going to start with SN2 reaction. Baba HSP is going to start with SN2 reaction. So everyone is ready? SN2. Just see the meaning of 2. 2 is indicating order of reaction is 2. Order of reaction is 2. That means it belongs to second order chemical kinetics. What is the meaning of that? Second order chemical kinetics. Or you can also say the full form of this SN2, full form is 2 for bimolecular and for nucleophilic S for substitution reaction. Now kids, what is the actual meaning of reaction is second, order of reaction is 2, it belongs to second order chemical kinetics, and what is the meaning of bimolecular reaction? Let me tell you in detail. Both the two things I'm going to tell you in detail, kids, just see to it. If I say there is one reactant and there is one nucleophile, two types of entities are reacting and they are giving you product. Now, if two types of entities, one is being substrate, this is known as substrate whose carbon is involved in the bond formation, and this is attacking agent. What is the difference in between these two? Remember that this is always organic. This is always organic. Always organic means its carbon is involved in the bond formation. Its carbon is involved in bond formation. Its carbon is involved in bond formation, and this can be organic or inorganic. Not necessarily it should have carbon. Now, my dear friends, if I say that rate of reaction, you know, rate of reaction, if your car is moving, how much distance the car is covering in what time, that is the speed. So the rate is the speed of this reaction, that in what time the reactants are getting converted into product. If more reactants, that is the concentration, definitely if more concentration of reactant is getting converted into more product, then we'll say the rate of reaction is too much. That means reaction is moving with very high speed. So rate is equal to K, rate constant into, this sign is indicating concentration, active mass. The substrate power is 1, and the nucleophile, the attacking agent, power is 1. Means this is the rate, definitely rate. This is known as rate constant. Rate constant, you can say rate constant, or you can say velocity constant, or you can say specific reaction rate. You can say specific reaction rate. Whatever you want to say, you can say. With respect to substrate, the power is 1, and with respect to nucleophile, the power is 1. The power 1 plus 1 means both are having equal power. What does it indicate? That if you increase the concentration of substrate, the rate will get increased. If you increase the concentration of nucleophile, the rate will increase. If you increase the concentration of both, the substrate and the nucleophile, the rate of reaction will increase much more time. This is the meaning of this reaction, that two molecules are reacting. Bimolecules means two molecules are reacting, and the order of reaction with respect to substrate is 1, with respect to nucleophile 1. 1 plus 1 is total is coming 2. Is the meaning clear to all of you? Now, once the meaning is clear, so remember that when whatever the reacting molecules are reacting and the order both are being same, because two molecules are reacting and order is also same. This is experimental concept. This is determined, order is determined experimentally. If you have seen chemical kinetics, determined, this is being determined what? Being determined experimentally. This is experimental concept. How many molecules are reacting, that is being the molecularity. I will say molecularity of this reaction is 2. Molecularity of this reaction is being 2, and the order of this reaction is also 2. And remember that when the molecularity is equal to order of reaction, the reaction will always take place in single step. Let me tell you, my dear friends, whenever for any reaction, if molecularity is equal to order of reaction, remember this thing, order of reaction. If this thing is there, if molecularity is equal to order of reaction, then always reaction will be elementary. What do you mean by elementary? Elementary reactions are single step reactions. Elementary reactions, these are very, very important point for chemical point of view also. Elementary reactions are single step reaction. Now, whenever there is single step reaction, always remember that will proceed without intermediate formation. Without intermediate formation. Will proceed without intermediate formation. That means no rearrangement will take place. No ring expansion will take place. Nothing will take place. Now, these things Baba has written on the basis of SN2, just SN2, and this SN2 is an experimental concept, that this 2 order is determined experimentally. Order is determined experimentally. Now, my dear friends, Baba has told you the experimental concept with the theoretical approach. This is the power of Baba, that Baba has told you the experimental concept with the theoretical approach. The thing which is determined experimentally, Baba has told you theoretically that how to find out whether the reaction is SN2, SN1, E2, even at least show me some hearts. That the thing which was experimentally determined, you must have studied in your chemical kinetics also, the thing which was experimentally determined, now you can find it out theoretically. Once if you are able to find out the order of reaction, you can also find out whether the 5-membered ring will convert into 6-membered ring or not, whether the hydride shift is going to take place or not, whether the methyl shift is going to take place or not. You can find out all these things immediately. Now kids, Baba want to see some likes. Baba is really working hard. So those who have not smashed the like button, smash his like right now. Everyone, if you have not smashed the like button, smash it right now. Yeah, now see, if this thing is clear, Baba is going to move ahead. Just see. If I tell you that I am having this reactant, just see to it. This is carbon and this is valency coming towards your side. This is indicating wedge formula, and this says that R1 is coming towards your side and this R2 is going away from you, and this R3 is in the plane of paper, and this X is also in the plane of paper. All the time X was saying, hey carbon, I don't like you, I don't like you, I don't love you, I will go, and I will go along with my electron as well as your electron. Your electron I will snatch, I will move like this. I want to go away from your life. See, carbon was always saying, please don't go. How I will live? I can't live without you. Please don't go. And one day, somebody approached like C2H5ONA or anything like that. ONA, this is the ionic bond. It has approached. Now, when carbon has seen this C2H5O negative, carbon said to this halogen, what that day what you were saying? You want to go? You want to go somewhere? X is saying, yeah, I want to go. Now see, this Na wants to capture this X, but X is forming a bond with carbon, loose bond, but not that loose, so that X can go immediately. What I'm trying to say, just try to find out. The carbon halogen bond is being polar. This is being polar bond, means cold war is going on. but it's not that weak so that it can break immediately. No, Na is not having that power to break this carbon X bond. Then what is going to happen? See, this C2H5O negative will come from the back side. Why from the back side? Let me show you why from the back side. This is BMO. Just see, this is bonding molecular orbital BMO. What I'm saying? BMO, bonding molecular orbital. Just at the back of this, there is ABMO. ABMO, anti-bonding molecular orbital, which is being empty, vacant. This is being vacant, empty, vacant. Now, whenever somebody wants to donate electron, it has to donate electron in the empty orbital, and somebody wants to gain electron, it has to take electron in the empty orbital. So this C2H5O negative will come from the back side. Will come from the back side. From here, just see kids. It will come from the back side. Kids, just see to it. And will attack on ABMO. Attack from back side. Back side. Now, the twist is there in the story. Just see. If I say this is X, just see, this is X. Can you see everyone? This is X and my hand is carbon. This hand is carbon. And if the attacking agent is NU, NU will come from the back side. See, from the back side. And if NU is not strong, it won't be able to remove this X from the carbon's life. So it must be very, very strong to remove this X from the carbon's life. It will say like this: cut, 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 cut. Now, from the life of carbon, X has gone and new nucleophile has formed the bond. The X has gone from this side and the new has come from the opposite side. See, opposite side. So it is inversion of configuration. The X was on this side and new is coming from this side. Is everyone able to understand? Do let me know in the chat section. That's why there will be some fight. Now see, carbon's valency was 4 and this was the X. X was in the family of carbon, but this time how many people are in the family? When there is a fight, during the fight, carbon's valency is how much? Do let me know if you are really able to understand. During this fight, carbon is having how much valency? This is very bad position, 5 valency, pentavalent. Very good. Kids, you are able to understand. So this is very, very dangerous position. Let me show you. In the life of carbon, there is pentavalent valency, kids. That is really very dangerous situation. Let me show you. Oh my God, what happened? Hey God, hey God, hey God. Where it's gone? Just a second, kids. Just a second. I think today's day is really full of. See, Oh, it's there. It's there. It's there, kids. It's there. Wow. Hey, God. Thank you. Today it's really what to say. Which day is today? God saved. Kids, really, it's all your blessings, God's blessings. What's happening today? I can't understand, kids. I can't understand. Oh God. Oh God. Now see, kids. What I was telling you. I was telling you. Oh, what is this? This is going to be position that is known as transition state. Transition state. Highly unstable. Highly unstable. Now, pentavalent. Carbon will be pentavalent. Carbon will be pentavalent. Pentavalent carbon. Now, see how it will look like. From the life of carbon, this X is leaving. This X is leaving and nu is coming from the back side. Nu, this is Nu, nucleophile. Nucleophile is coming from the back side. Nucleophile has not formed the bond and X has not gone. And in the life of carbon, there is R1, there is R2, there's R3. Can you see? This is pentavalent, highly unstable position. But remember that this X has gone too far away. Nucleophile is not able to reach up to carbon. It is pentavalent, but hybridization is still sp2. sp2 hybridized. This is point to be noted, my lord. If you think about inorganic chemistry, whenever pentavalency is there, like PCl5, you will say sp3d hybridization. But here they are not forming the hybrid orbitals. These are only hybrid orbitals. Right now they are at 120 degree. 120 degree. So after some time, X will leave this carbon and this nu will be the part of carbon. So nu will say, hey, R1, R2, R3, just go and shift. You just go on another side. I don't want to see you on this side. R1 is over here, R2 at this place, and R3 over here. Just see, this was the reactant, this is the product, and this is simultaneous breaking and making of bond. Simultaneous Bob and Mob. What is Bob and Mob? Breaking of bond and making of bond. Breaking of bond and making of bond. Breaking of bond and making of bond. Now see, kids, this is new bond form. X has gone from the east side and Nu has come from the west side. You will say inversion of configuration. Inversion of configuration. Now, my dear students, suppose if I am pointing, my head is pointing towards your side, and if I move like this, now this is inversion of configuration. If my head goes downside and the legs comes upside, upside down, downside up. This is inversion of configuration. Everyone is able to understand? Everyone, just to let me know inversion of configuration. Till now, if it is clear, show me the green signal. Let me see your chats. Golu Kumawat, Sweta, Vijay Kumar. Wow, Vijay Kumar, that's really fantastic. Johra, Joha Mehraj, I can see your chats, kids. Do let me know. Till now, if it is clear, Victor, Selva Kumari, Madhu MBBS, Ramesh, PDF. Yeah, definitely I will send you the PDF, kids. Kids, this chapter holds a whole lot of weightage. Then I will deal with all the reactions of your alkyl halide and haloalkanes haloarenes. First of all, do let me know if everything is clear to each and every one of my dear students. Vijay Kumar, I can see Ramesh, yes, Dhanvant, oh my god, all my kids are there. Baba HSP's army is there, HSP and army is there, Chai 2 is there, Vijay Kumar, Victor Selva Kumari, Vijay Kumar, yes, I can see Lakshmi Tharani, everyone. That's really fantastic. That's really fantastic. Now, if I ask you one question, before asking question, remember that if this carbon is chiral, in case of chiral carbon, this inversion will be known as, in case of chiral carbon, inversion will be known as, let me write down on another page. Let me write down first over here. Inversion will be known as Walden inversion. Walden inversion. In case of chiral carbon, inversion will be Walden inversion. Now, if I ask you factors affecting rate of SN2, will you try to give the answer? These R1, R2, R3 should be sterically hindered or least sterically hindered, small R1, R2, R3 for better reaction, because the nucleophile has to come, and attack from the back side, and they are sterically hindered. If they are being sterically hindered, this nucleophile will not be able to approach this. That is the steric factor. So, this alkyl halide must be least sterically hindered or more sterically hindered. Do let me know. This alkyl halide will be least or more. So remember that factors affecting rate of SN2 reaction. Factors affecting SN2 reaction. First thing, first point, R must be least sterically hindered, Now for this, if I say R must be least sterically hindered, that means if I say methyl halide, NCERT says methyl halide's rate will be maximum, then ethyl halide, and then NCERT says 2 degree alkyl halide, and then NCERT says for 3 degree alkyl halides it's negligible means approximately tending towards zero. Are you able to understand why NCERT is talking like this? This knowledge I am giving you according to NCERT, not according to rank deciding question. I will tell you after this rank deciding question. This is methyl halide, least sterically hindered. Now this is ethyl halide. This is also 1 degree. This is being 1 degree. This is also being 1 degree. This is being 2 degree. And this is approximately 0. Because there is no space to attack from the back side because of too much steric hindrance. Too much sterically hindered. Too much sterically hindered. Am I right, kids? If you see your NCRT, there one 3D diagram is given for the representation that how much sterically hindered they are. Is this point clear to all of you? Is that point clear to all of you? Now, if you want to see for your competition level, I am going to tell you, but before that, the story which I have told you, right? In the starting, I have told you story that 1 degree, then 2 degree, and 3 degree, no liking for 3 degree. Just remember that doctor and patient story, that SN2 was liking methyl halide, then 1 degree, then 2 degree. Can you correlate that story? Everyone do let me know. Can you correlate that story with this? Can you correlate that story with this? Now do let me know. That story, the magic story, that scientific story Baba has told you. Now can you correlate that with this? Yes. Now I'm going to tell you about for the first rank. Now for rank deciding, for doing rank deciding questions, you should know each and everything in detail. You should have to have knowledge in detail. Just see, heteroatom at beta carbon, heteroatom at the beta carbon with respect to leaving group was halogen, has 10 to power 5 times more rate. Now let me show you those type of compounds. If I write down compound like CH3, CH2, O, CH2, CH2X. Now see, this is your halogen positive, this is your alpha carbon, this is beta carbon, this is heteroatom. Other than carbon, this is your heteroatom. This is attached on beta carbon, or it could be given like this. Question can be given like this also. CH3, C double bond O, CH2X. Now see to it. This is your alpha. Sorry, positive, it's okay. This is your alpha, this is your beta, and this is heteroatom. They will have 10 raised to power 5 times more rate. Now you will ask, sir, what's the reason behind it? Everyone will ask, what's the reason behind it? Reason is neighboring group participation, NGP effect, but not in syllabus. NGP effect, but not in syllabus. What I'm saying, this reason is not in syllabus. Reason is not in syllabus, but these compounds are in syllabus. What I'm saying, reason is being not in syllabus, but the compounds, they are, yes, they are in syllabus. Now after this is maximum rate, then there is methyl halide, then there is ethyl halide, that you know very well. Then there is isopropyl halide, 2 degree. And now after this, there is one very, very important compound. This compound is CH3, CH2X. This is a special compound. It's looking 1 degree, and yes, it is being 1 degree. It is looking 1 degree, and also it is 1 degree, but it is too much sterically hindered. In the name of 1 degree, it is so too much sterically hindered 1 degree. Too much sterically hindered 1 degree. Too much sterically hindered 1 degree. So very, very less rate. Its name is neopentyl halide. Neopentyl halide. And you know that for tertiary the rate is 0%. 3 degree alkyl halide, the rate is 0%. Everyone got it? These are having maximum rate. Then after this, these are also 1 degree. See, these are also 1 degree. This is also 1 degree and this is also 1 degree, but all two 1 degree, and this is also 1 degree. This is also 1 degree. See, 1 degree, 1 degree, 1 degree and 1 degree. All the four are 1 degree. So, how the examiner will ask questions? See to it. Examiner will ask question like this. Arrange the following question. Arrange the following in decreasing order of rate for SN2. Rate for SN2 reaction. Now, options will be given like this. A option is CH3, CH2, Br plus C2H5ONA. B will be CH3, O, CH2, CH2, Br plus C2H5ONA. C option will be CH3, 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 Br plus C2H5 or E2ONA, same thing. And D option will be CH3, Br plus ETONA. Now do let me know what should be answer. I am not going to give you poll. I will not write down the options. You have to arrange in the decreasing order. If you are able to understand, do let me know in the chat section that yes, what should be the answer. Let me check it out. I'm waiting for your answer. Let me have a sip of water also, then I will see to it. So people are writing BDAC. Let me check it out. BDAC. B, fantastic. D, fantastic. A, wow. C, claps for you kids. Baba is clapping for you. You are really going to get the best rank. You are studying like you are in front of me. Salute kids. Salute. Baba is giving you salute. Accept my salute and say, yes, you have done a great job. Great job. Now see kids. Leaving group tendency. Because factor number 2, Baba is going to deal with factor number 2. Factor number 2. What is that? Factor number 2 kids. The Rx was made up of 2 parts. First part we have seen type of R. This already we have gone through type of R. Now this is leaving group. This will go with negative charge. So this is being leaving group. Now kids, if it is going to leave, it will be known as leaving group tendency. That will be known as what? Leaving group tendency. Leaving group tendency in shortcut LGT. LGT. Now, after leaving this R, the X will have negative charge. Who can leave easily? Whose negative charge is stable on that? No one is having negative charge stable. No one is having any charge stable on it. But comparatively, if I say comparatively, who is comparatively more stable? Whose charge is less or more? Less is the charge, more will be stability. So, by keeping this thing in our brain, less is the charge, more will be stability. Am I right? More will be stability. Am I right, kids? So that means this conjugate base is going to be stable, and who is going to form more stable conjugate base? Stronger acids form weaker conjugate base, and weaker bases will be more stable, and that's why more good leaving group. Sir, we are unable to understand. We can't get it. Let me write down, then only you can understand. See, stronger acids form weaker conjugate base, and weaker conjugate bases are stronger bases. Weaker conjugate bases are stronger bases. If I write weaker conjugate base, weaker conjugate will be more stable. Sir, this point is not clear. I will make it clear. First, let me write down weaker bases are good leaving groups. Weaker bases are good leaving groups. Now, how many of you want that I should explain these 2 points? How many of you are in need of these 2 points to be explained in detail? If yes, show me the fire in the chat section, then I can understand that you want these 2 points to get in detail. Let me check it out. How many of you are in need of these 2 points in detail? Yes, I want to see. It's fast. Yes. Everyone fast. Okay, now see. If I say I'm having HF, HCl, HBr, HI, then could you please help me to know that negative charge is more stable on? If I write down this point, that negative charge is more stable on, fill in the blanks please. Negative charge is more stable on dash, fill in the blank. Kids, let me see your knowledge. Let me check it out in the chat section. Yes. Number of students are writing more electronegative atom, but remember that size matters a lot. Negative charge is more stable on biggest atom. Remember that, biggest atom, not more electronegative atom, biggest atom. And that's why you kids are getting failed, because you are not having this knowledge. You are always saying that negative charge is more stable on more electronegative atom. Always remember that. First of all, we have to see the size matters a lot. Negative charge is more stable on most electronegative atom, so this will be most stable, and this will be least stable. That's why, let me prove it also, and this is the reason why HF is least acidic, and HI is most acidic. If I give you the pKa value, then it is +3 and it is -10. Now stronger acid will form weaker conjugate base. This you know very well, weaker conjugate base, and I have written weaker base is more stable, and this can survive without carbon, and that's why it is best leaving group, best Lg leaving group. How many of you are able to understand each and every point very clearly, kids? They are getting matched. Do let me know in the chat section. I want to see in the chat section that how many of you are able to understand, kids. Let me see your chats. How many of you got it? And everyone, those who have not, smash the like button. Smash it, kids, right now. Mark your attendance. I want to see your attendance in the chat section. Everyone, mark your attendance. Break you will get at 9. At 9, I will give you break, kids. One break. I will give you first break at 9. Okay, kids? Is that okay? Or you want right now? Baba the Killer, thank you. Crystal clear, thank you. Okay, then I will give you break at 8:30, right? Okay, at 9. People are asking for break. Some are saying at 9, then I will give you at 9. That's fantastic. Okay, okay. Now, see, kids. Now, I'm going to give you one more theory for this. If you see another approach, if you want to see another approach, if you don't want to go with that approach, Baba is going to give you another approach. Just see. If I say carbon, carbon is 2p, fluorine, carbon chlorine, carbon bromine, carbon iodine. Carbon is always 2p. Now, this is 2p. Bond of equality is good. Remember that. Bond of equality is good. Right? Now, out of these four, 1, 2, 1, rana, mono, nale, out of these four, which is weakest bond? Carbon is saying, hey, iodine, you know, where iodine is here? Fluorine, chlorine, bromine, iodine, 1, 2, 3, 4, fifth period. Carbon is saying, hey, I'm very small, I'm 2p, and you're 5p, too big, so big. So this is the weakest bond. And that is being the strongest bond. Let me complete this SN2 reaction. Whenever this SN2 reaction is going to get completed, I will give you break, kids. Okay. At that time, I am going to give you break. Now, my dear students, you can see out of fluoride, chloride, bromide, iodide, who is going to be the best leaving group? So, I can say easily iodide is a GLG. What do you mean by GLG? Good leaving group. Iodide is being GLG, good leaving group. Everyone getting my point? Now see, leaving group tendency, Baba is going to write leaving group tendency. In this leaving group tendency, I will write the whole sequence so that in the examination, you should not suffer. NH2, RO negative, OH negative, fluoride negative. These four are very, very strong base, very, very strong base. So very, very poor leaving groups. And that's why you must have seen they cannot give reaction easily. Now after this, fluoride, chloride, bromide, iodide, and tosylate. What is this tosylate? Tosylate is best leaving group, best leaving group, best LG, best leaving group. Now, these are very poor leaving groups. This is the leaving group tendency in tosylate. Let me tell you what is being tosylate. Is everyone ready for the tosylate? Just see, just check it out. NH2 negative, RO negative, OH negative, fluoride, chloride, bromide. If you're not able to understand, do one thing. You add H to them and then you will get base, ammonia, ROH, water, HF. weaker bases form stronger conjugate base. No, sorry, weaker acids form stronger conjugate base. So these are weaker acids. Ammonia is a base, so definitely it is a weaker acid. It is a weaker acid, and weaker acids form stronger conjugate base, right? Now let me explain tosylate. Tosylate is also written as OTS. OTS. Its full form is paratoluene sulfonate. Paratoluene sulfonate. Today I will give you mind map also, kids. Paratoluene sulfonate. 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 So see, it is paratoluene sulfonate. Now you can see very clearly its acid must be this, paratoluene sulfonic acid, and sulfonic acid is a very strong acid, very strong acid, very strong acid will form very weaker conjugate base. Weaker means not in need of proton. So not need of protons, so stronger base or weaker base. Weaker base, weaker conjugate base is stable one. Stable. Now this point is clear to all of you. Now on the basis of this, I am going to give you question. Are you ready for this? Should you need simple question or should I give you tough question? Kids, do let me know in the chat section. You need simple question or you want tough question? See, I will make you kids that strong. Me and Vasim sir will make you that strong in chemistry that you are going to get full in chemistry. Ambika ma'am, Pankhui ma'am will make you that strong that in bio you are going to get full on full, and physics too, sir. You know, your favorite sir, Kailash sir, Yava sir will make you in physics. Now see kids. So Baba is going to give you question. Arrange the following in decreasing order of rate of SN2 reaction. Question is, arrange in decreasing order of SN2 rate. Just see to it. A is CH3. I'm going to give you tough question, rank deciding question, right? Chloride C2H5ONA. Another question means another option B, CH3 CHBr CH3 C2H5ONA. These are the questions of IIT AIMS. Already that these questions have been asked. CH3O CH2 CH2I ETONA. Now D option, CH3 CH2 Br ETONA. Now let me check it out what your answer is going to come and see to it whether you are going to get correct answer or wrong answer. Let me check it out, kids. Everyone do let me know. Fast. CDBA. It's if your answer is correct, then I will give you salute. So see, heteroatom, and this is best leaving group, good leaving group, and heteroatom is there. So definitely this is going to be number one. Now this 1 degree, and okay, D. After this is at the last, and out of this is the good leaving group if you compare EBA. Kids, now Baba is not going to teach you. Claps. You just go and find out any other teacher, good teacher. Baba is not that good. You are able to understand so quickly. You can answer all the question in decent way. How is it possible? So, should I give you one anaconda question? Anaconda means, I'm saying like that, Baba is not that capable of teaching you. You are smarter than Baba. You are more intelligent. You have become even more intelligent than Baba. Then how Baba is going to teach you? Now, you want anaconda question so that you should get negative marks over here. How many of you are in need of anaconda question? See, anaconda means, first of all, let me tell you, anaconda means you are going to get negative marks. Anaconda means tricky. Anaconda means tricky question. This time you will get failed. Just see. Arrange in decreasing order. Before giving you question, I want one promise, kids. I want one promise from your side that you are going to stay with me up to the last, because I want to tell you each and every single point starting from the scratch up to the first rank. First of all, make a promise in the chat section. I want to see that promise, that whatever energy is required, whatever the time is required, you are going to be with me. I can see everyone's promise. I can see the names also. SP Arjunan, Dhanwant, Ramesh, Saikaran. I will keep on giving you breaks. Don't worry for the breaks. And it's really for them also, those who are thinking that organic chemistry pidika radu customer. I would like to say, Allah, it's Romba Sulvam, means it's easy, it's not tough. Baba will make it easy. Okay, that's fantastic. Now see kids, see to it. A is CH3, CHONA, CH3, CH3, I, B is CH3, CH2, Br, CH3, CH, ONA, CH3, C is CH3, 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 Br, CH3, ONA, D is CH3, CO, CH2, I plus ETONA. Let's see this time. Everyone is not going to get full marks. I know that. This time it's a bit tough. So how many of you are going to get full marks? Let me check it out. Yeah, you can take your time. Kids are writing DABC, some are writing ACDB. Let me check it out. BACDC. Everyone is writing different answers. Okay, let me clear it. Let me make it very clear. Kids, those who have not smashed the like button, please smash it. Hit the like button. Okay, now let me show you what should be the answer. See, always first try to find out which is reagent. This oxygen is involved, so this is reagent, not the reactant. Its carbon is involved, this is reactant. That is 1 degree. Okay, see, its carbon is involved, this is a reactant. that is a reagent. Now here, this is the reactant 3 degree, reactant, and this is being the reagent, and here this is heteroatom. So definitely D. After D, this is 1 degree A, and after that A, it is 1 degree B, and definitely this is going to be C at the last. How many of your answers is right? Show me the hearts. If your answer gone wrong, show me the fire. Hearts and fire. Let me check it out. How many of you are getting hearts? How many of you are getting fire? Let's see the race between heart and fire. I know that you kids are really transparent. You're not going to cheat. So kids, one thing is R clear, one thing is leaving group tendency is clear. Now third thing comes the nucleophilicity, and it will require some time, some patience, some time, some patience. Third factor is nucleophilicity. So are you ready for this? Nucleophilicity, and it needs some patience to understand. Factors affecting nucleophilicity. It holds a hell lot of weightage. If you're not giving proper time to this, you won't be able to answer it. Very, very important. Factor number 1, and you have to follow the sequence. Factor number 1, negatively charged entity is a better nucleophile than its own neutral form. Kids, remember that. What I have written, negatively charged entity is a better nucleophile than its own, means its own, not I'm comparing with somebody else, its own neutral form. Let me give you example of it. If I say OH negative is a better nucleophile than HOH. Now, some of you will say, sir, both are same. How can you speak like this? How can you say like that? Remember that one point, water is water. Water doesn't mean OH negative. Water is having partial negative and partial positive charge. You cannot say that is OH negative, no. So it can be given like this, or they can give you OH in the form of NaOH, this is also OH negative. They can give you KOH, that is also OH negative, because there is ionic bond. But water is water. Water is never OH negative. Never confuse with that. Water is not OH negative. Because water is not going to ionize so easily. You must have studied in your ionic equilibrium that water cannot ionize that easily, kids. Now, second example of it only I am going to give you. If I say C2H5O negative, not only C2H5O negative, any RO negative is better than C2H5OH. Now, my dear student, it could be given like this, or they can give you it in the form of this. C2H5ONA, they can give you C2H5, okay, like this. So I hope this point is very much clear to all of you. That Negatively charged entity is always a better nucleophile. Why better nucleophile? Let me explain. Let me explain. Just see to it. It is having complete negative charge. Complete negative charge. And that is having partial negative charge. So definitely partial negative and complete negative is having more negative charge, means highly unstable. This is highly unstable. So it is in more need of somebody to give its electron. Is this point clear to all of you? Is this point clear to all of you? Yes. Now second point, just see the second point. Factor number 2. Factor number 2. Very, very important. If the size of an atom having the negative charge, is same or approximately same, then nucleophilicity is being directly proportional to basic strength. And my dear students, basic strength you have already studied in your GOC. But then also I would like to tell you, because otherwise you are going to lose your marks. You will lose your marks. So see kids, I'm going to explain it because there are a number of twists, ups and downs. Just see. If I say that I'm having CH3O minus, I'm having OH minus, I'm having water, then are you able to understand? Is everyone able to understand this thing? Nucleophilicity order. Either I can say nucleophilicity or I can say basic strength. Why? Why it's being like this? That is being neutral. This is being neutral. Neutral means least basic, least nucleophilic. They are negatively charged, but this is giving electron through plus I. I hope that you are able to understand. Everyone is being able to understand. Now, if I talk about B category, if I write it like this, CH3, CH2O negative is a better nucleophile than CH2 double bond CHO negative. Why is like this? You can see very clearly this charge is being localized. So highly unstable, and this charge is doing resonance. This is coming over here, this is going over there. So delocalized charge is less due to SBR. What is the full form of SBR? Stabilized by resonance. So basic strength and nucleophilicity is in the same order. Now let me give you the best option, that C. If I say CH3 negative, better nucleophile than being NH2 negative, is better than OH negative, then better than F negative. Same is the base strength, same is the nucleophilicity, because negative charge is more stable on more electronegative atom if the size is same. Here the kids, those who have given that negative charge is more stable on more electronegative atom, then definitely this point is going to be correct. If the size is same, then negative point is more, means negative charge is more stable on more electronegative atom. Clear kids? Now people will say, sir, what do you have written? Let me write down once again, kids. Sorry, bad handwriting. For bad handwriting, negative charge is more stable on more electronegative atom. Okay, kids. Now, kids must be saying, sir, I was saying this only. At that time, you said biggest atom. It's here. The size of atom is same. They belong to the same period. These points are clear to all of you. If this much is clear to all of you, I would like to say something. See, there is a twist. If we consider about this base, before telling you this base, I would like to tell you one story. Have you seen the movie Spider-Man? Have you seen the movie Spider-Man? Just do let me know if you have seen. Now, once if I'm asking, have you seen the movie Spider-Man? You will say, which part, sir? Any part, any part. There was one Spider-Man, spiky but powerful. Powerful, thin and spiky, muscular body. There was one Dr. Octopus having many tentacles. So Spider-Man was moving like this, in very, very small, narrow space. He was able to move, he was able to manage. But Dr. Octopus was moving and he was breaking all the bindings because he was so heavy with tentacles that he cannot move. So Dr. Octopus was sterically hindered. Am I right? Now, when Dr. Octopus is sterically hindered, this is Dr. Octopus like. This is like Dr. Octopus. Dr. Octopus. Too much sterically hindered. These are the tentacles. Too much sterically hindered. Let me tell you one story, that if Ramu is inside his house, his home, house, whatever you can say, and there is one lion and there is one elephant and the door is open, Ramu has to be more afraid of whom? Lion or the elephant? My dear friends, elephant cannot enter inside the house because it is huge, huge animal. So its body will stuck somewhere. But lion is like Spider-Man, slim and spiky. So nucleophile must be slim and spiky so that it can easily approach to carbon. That is, carbon can be positively charged or partially positively charged. If it is like Dr. Octopus, it won't be able to reach up to that carbon. So it's not a good nucleophile. See, too much sterically hindered. So in most of the cases, in almost many cases, or 90% cases, it can't act as nucleophile. It can't act as nucleophile because of steric hindrance. It is a very, very strong base. Very, very strong base because it is highly charged and its neighbors, they are giving electron through plus I. They are intensifying the charge. Charge is too much. Magnitude of charge is too much. I would like to say Charge got intensified. Charge got intensified. So it is being too much in need of proton but cannot attack carbon because it is too much sterically hindered. Now you will ask, sir, why only 90%? If I say methyl halide is least sterically hindered, so it can easily reach. With methyl halide will act as strong nucleophile, will act as with methyl halide, for methyl halide, or with methyl halide, it will act as strong nucleophile because this is sterically hindered, but this is not sterically hindered. This is the smallest alkyl halide. Kids, got it? Now let me tell you the solvent effect and then I will give you the break. Kids, after solvent effect, I will give you break. Okay? Kids, if this much is clear to all of you, show me the green signal, hit the like button. I want to see your support, your understanding, your bonding, each and everything. That if you are able to understand, show me the green hearts, green signal. Very good, very good. I can see, kids, I can see. Now I'm going to tell you effect of solvent. I hope that everyone is ready. Solvent, how solvent is going to affect nucleophilicity. That is very, very important, kids. Very, very important. The factor number, which factor, kids? Which factor? Do let me know which factor, kids. Factor number 1, 2, third factor. Effect of solvent on nucleophilicity. So kids, let me tell you first effect of PPS. Now first let me write down the whole theory, otherwise you will get confused. Effect of PPS, effect of PS, effect of PS, effect of NPS. The nucleophilicity order here, it will be iodide will be the best, IBr, Cl and F. IBr, Cl and F. This should be the nucleophilicity order. Here the order will be just opposite: fluoride, bromide, iodide, and here once again it will be iodide, then bromide, then chloride, then fluoride. Now see kids, first cram it, then I will explain it. First everyone cram it and then I am going to explain it. In these two, it is being remaining same. Here and here it is being same. And here it is different. Now, you must be asking what are the full form of PPS, PAS, NPS. I will tell you each and everything. But first of all, remember this. Now, PPS is polar protic solvent. Polar protic solvent. PAS is polar aprotic solvent. NPS is non-polar solvent. Non-polar solvent. Now, what is the meaning and how they are affecting nucleophilicity order? How many of you are ready to understand it? Everyone, I hope that everyone is ready to understand it. First of all, I am going to tell you PPS. Now see, PPS. PPS, solvent which is polar and can donate proton, polar as well as can donate proton. Can donate what? Can donate proton. Examples like water, very good solvent, alcohol, carboxylic acid, etc. They will ask you like this. Now, how they are going to change the nucleophilicity order? Just see to it. Gets, if I say in gaseous state, who is biggest? In gaseous state, who is being biggest? In gaseous or molten state, in gaseous or molten state, my dear students, iodide is being the biggest, then bromide, then chloride, and then fluoride. It is like this. The one who is biggest can't move fast. If I compare the lion and the hippopotamus, who will run fast? Definitely lion is going to move fast. So this is the biggest one, can't move fast. But my dear friends, once it is going inside the water, let's see how it will get changed. This is, let us suppose this is the size of iodide, this much is the size of iodide, and this much is the size of fluoride. Who can form better hydrogen bonding? Definitely fluoride will form better hydrogen bonding, and the HOH, 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 they will surround it like this through intermolecular hydrogen bonding, and one more layer of water will surround that. So the size of fluoride in water has gone from here to here. This is the size now. Solvated fluoride, we will call it. It's not fluoride, it is solvated fluoride. Solvated fluoride. It's like, suppose any actress has come to your city. Any actress has arrived to your city. Any actress. Then public will come over there and they will ask for giving autograph. This is the public direct in contact with that actress, and this public is waiting for their turn. This public is waiting for their turn. So now the size of fluoride is this much. This much is the size of fluoride. Are you getting my point, kids? The size of fluoride will be this much. After getting solvated, now this is fluoride size, not only that much. This is the size of fluoride. Everyone is able to understand. Solvated fluoride, maximum solvation or hydration, or we can say maximum hydration. Now my dear students, iodide is like any person not having that fame, person with less fame. So some water molecules will come. Oh, you have arrived. Oh, what you have come over here? We don't want to see. You have taken boats, but nothing you have done for the society. You haven't done anything for the society. For what you have come over here? Just go. Go away from our village. Go away from our place. So the iodide was really big, but after solvation, this is the only size. Now, this is the size of solvated iodide. It's who is bigger in size in water? Who is bigger in size in water? This is bigger and this is smaller. Solvated iodide, that means I can write iodide aqueous is the smallest, and solvated fluoride is largest in size. I hope that everyone got it. That's why iodide is best nucleophile. So I can say very clearly that nucleophilicity is inversely proportional to size of solvated ion. Are you getting this point? If this point is clear to all of you, then do let me know that yes, Baba, it is clear. Now remember one thing, one note I'm going to give you. The note is, even when the solvent is not mentioned, suppose if somebody has called you that yes, please come, let's have party. So they haven't told you that what they are going to serve you, then definitely they will serve you water. And whenever you are going to some hotel or some place, then you are not asking anything, then the waiter is going to serve you water. So whenever the solvent is not mentioned, whenever the solvent is not mentioned, whenever the solvent is not mentioned, always take it to be aqueous. Always it must be taken aqueous. Must be taken what? Aqueous. Aqueous. Is this point clear to all of you? I want to see some hearts in the chat section if this point is clear to all of you. I can see less people. They have gone for dinner. Even I am feeling hungry, kids, but Baba is going to tell you up to the effect of solvent, then I will give you break. Everyone do let me know if it is clear to all of you. I want to see some green signal in the chat section, kids. Yes, kid. Yes. Now, let me tell you effect of polar aprotic solvent. Polar aprotic solvent. Let me show you effect of polar aprotic solvent, kids. Polar aprotic solvent. Solvent which is polar but can't donate proton. Is polar but can't donate proton. Let's see the examples of such solvents. DMSO. What is DMSO? Dimethyl sulfoxide. Dimethyl sulfoxide. How it will look like? Dimethyl sulfoxide. DMF. Dimethyl formamide. Dimethyl formamide. These are the examples, or you can say dry ether. Dry ether. These are some examples of polar aprotic solvent which they are going to ask. We should know. Now, one more example, let me tell you. Sometimes they can ask dimethyl acetamide, DMA. Dimethyl acetamide. Dimethyl acetamide will look like this. See, kids, means exactly it will be, that is formamide. This will be dimethyl acetamide, my dear students. Now see how they are going to affect the nucleophilicity. Let me tell you, my dear students. Are you ready for this? Are you ready for this? See to it. Let me tell you, polar aprotic solvents, mainly solvates the cationic part of reagent. Whereas anionic part remains, comparatively free, Now question arises, why it is like that? Now see kids, I'm going to explain it. Just see to it. If I write dimethyl sulfoxide, this is your dimethyl sulfoxide, carbon H, 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 carbon H, H, H. This is the DMSO. This is being your DMSO. Now just see, in DMSO, this part is sterically hindered and this part is free. The cationic part is, you can see, sterically hindered. This part is sterically hindered. Now if I say that there is being NaF, Na positive, F negative, and there is being NaI, Na positive, I negative. Okay, this is your solvent, this is your attacking part, and this is here you have got your reactant, carbon and X. See, three parties are there. Just see, three parties are there, not the party to enjoy. These are the three types of molecules. Can you see, kids? Now this oxygen is saying, I can capture you, Na plus, I like you. This oxygen is saying, I like you. Now sulfur says to fluoride, because it is positive charge, I like you, but fluoride is saying what to do. You are too much sterically hindered. Too much sterically hindered. Your family members will not accept me because they will not allow too much sterically hindered. So we are going to approach towards carbon. We are going towards carbon. Are you able to understand? This is too much sterically hindered. This sulfur plus is liking fluoride and iodide, but because of the steric hindrance, fluoride and iodide cannot go and combine with this. This is the solvent. This solvent can't form bond with anionic part. Solvent can't form bond with anionic part. Why? Due to too much sterically hindered. So this was having this much of size and that was having this much of size. That means the size will not get changed. Size of fluoride and iodide will remain as it was in the gaseous state. The fluoride was in the gaseous state smaller and this was larger. So larger will move slowly, and that will move fastly. That is the best nucleophile. So fluoride, then chloride, then bromide, then being iodide. You got it? This is the nucleophilicity order in PAS. If it is clear to all of you, show me some green signal, kids. I want to see some green signal that yes sir, it is very much clear to us. Yes kids. Kids, yeah, thank you. I'm having water, so I can see your chats, and I'm having water also. Now, non-polar solvent. After this non-polar solvent, Baba is going to give you break, dinner break. Okay, okay, kids. Now see, effect of NPS. NPS means neither polar nor protic, like carbon disulfide, CCl2 or CCl4, etc. So these solvents neither solvate cationic part nor anionic part. So how they are going to affect? They are saying we are just providing the medium. We will not do anything to you. So how they will decide? Now see, if I say NaF is like this, NaCl is like this, NaBr is like this, and NaI is like this, you can easily find these are the bond dissociation energies. Can you see, kids? Bond dissociation energies. This one is having least bond dissociation energy, least bond dissociation energy, so will break easily, Now kids, here is the story of that hare and tortoise, hare and tortoise. This was sleeping. This is a strong bonding with the sleep, strong bond with the sleep. This is rabbit, but strongly bonded with the sleep. Even though fluoride can move very fast, but it's tied up with the sleep, and this is moving slowly, but it is continuously, because it is least bond dissociation energy, will break easily, and will break easily, although it is moving slowly, and slowly will reach up to carbon. Slowly will reach up to the carbon, and that's why iodide will move slowly but will continuously keep on moving, and that's why this is the order of nucleophilicity. So kids, I've told you till now this much. I hope that this much is clear to each and everyone. I want to see in the chat section, and then I'm going to give a break. Thank you. It's me, Nirmal. You're liking it. Wow, thanks. So subscribe this channel and tell to each and everyone after the break. You have to come with lot of energy, because too much to go and too much to tell you. So it's a break, dinner break, a little bit lengthy break I will give you. So from this time 21 to 10, that means 9 to 10 to 9:40. Should I give you up to 9:40? 9:45. Yes, kids, up to 9:45, right? Let me give you this break up to 9:45. So it's dinner break. Let's meet at 9:45 with lot of energy, with lot of energy. It's promise me, otherwise I am not going to give a break. You know that Baba can stand over here for 12 hours without eating. So first, make a promise that you will come with more energy and with more friends. Tell everyone that yes, Baba is going to give you the best, the best. Baba is going to give you SN1, SN2 already I am giving you most fantastic examples. Baba is going to give you ARSN1, ARSN2 along with the mind map after this break. So I want to see your chat that yes, yeah, that's fantastic. That's fantastic. I can see. Yeah, wow, promise. It's a good what promise. Yes, it's meet with energy. Definitely. Lot of energy, right, kids? Hey everyone, I'm back. You can see the punctuality. Baba's punctuality. Can you see, kids? Baba is 1 minute before only in time. So, kids, are you with full on Josh? If yes, then definitely we are going to rock with after SN2 reaction, SN1 reaction, then ARSN2, then ARSN1. And I will complete the whole chapter in these reactions. Then definitely elimination is also there. So too much time I'm going to take because it's a lengthy chapter and it holds a whole lot of weightage. Means at least I can say 5 to 6 questions will come definitely from this chapter. So how's the Josh? What I can see, kids, everyone is not back. What I can see in the chat section. So should I wait for 1 to 2 minutes? Because I am early. Let me see, kids. Yeah, I can see. So let me start. So just let me go ahead because long journey to go. So kids, if you're ready, I want to see Josh in the chat section. Show me some Josh in the chat section. I want to see some Josh. Yes. Now, after telling you all these things, let me give you one example. Question is, let me draw. Here I have written bromine. Here I have written CH3. Here I have written H. And here I have written C4H9 normal alkyl, N-alkyl. Now, if examiner has given this is dextro, and he has given C2H5 ONO, ONA, and he has left like this, and he's saying already he has given SN2 reaction. He's talking about SN2 reaction. Already it's been given, SN2 reaction is given. Now he's asking about the configuration of product. Product will be, the question is, product will be, let me give you options. First option, Lavo. Second option, dextro. Third option, both. D option, any one, either dextro or Lavo. Anyone, either dextro or levo. Either dextro or levo. Either dextro or levo, right? Or levo. Either dextro or levo. Now do let me know. You will go for which option? I want to see in the chat section. Kids, what's your answer? Let me check it out. Levo. Everyone is going for Levo. And one kid, that is Dhanvant, has gone for A. Darshini has gone for A. And definitely kids, answer correct one is this one. Ask me why. Now everyone, ask me why this is the answer. Just ask me why this is the answer. And then Baba will explain. See kids, This is chiral carbon, definitely this is chiral carbon, okay. The product formed will be like this. This will be your product, CH3, H, C4H9 normal, and OC2H5 will be over here. Could you please let me know one thing? Could you please let me know one thing, that is the product isomer of reactant? Is the product isomer of reactant? This product is not isomer of reactant. Isomer of reactant, my dear students, let me tell you, product is not the isomer of reactant. If the product is not the isomer of reactant, then how can you say that will be LEVO? If these two are the reactant and product would have been the isomers, then you can say dextro will form LEVO. This is some another compound. It can be either dextro or LEVO. We cannot say. Yeah, we can say one thing. If they have given you like this is 1 according to CIP rule, and this is 2, and the arrow is going clockwise, and hydrogen is over there, so definitely it is going to be the S configuration, and this is S configuration. We can find out its configuration 1, 2, arrow is going anti-clockwise, hydrogen over there. R configuration, S configuration is absolute configuration. You can find it out very easily, but you cannot find out whether it is being dextro or LEVO. We can say only it will be either dextro or LEVO, because this is only one product. If everyone got it, if everyone is able to understand, I want to see some fire in the chat section, josh in the chat section, because after the break you must have become little bit lazy. So I want to see some fire in the chat section. Yes, you got it and you missed it. Everyone missed it, and this question has been asked in IIT examination 8 years back. 8 years back they have asked this question, my dear students. Now this was all about SN2 reaction. Now Baba is going to tell you about what? SN1 reaction. Is everyone ready for SN1 reaction? SN1 reaction. Is everyone ready for the SN1 reaction, kids? Has become a bit slow. What he is saying, can understand. Okay, not working. Let me wait for some time. It has also become tired, kids. Even the board has become tired. The board is saying again, happened. Let's wait for a few seconds. Let me see what happened to the board. It's just wait for a second. Today I have told you, na, today is the day of number of things. Can't understand what happened. Everything is taking by exam. Here, there, here, everywhere. Can't understand what's going on. What this board is. Let me decrease the temperature. Let's see what happens. Let me decrease the temperature, then see. Kids, till that time, let me tell you, SN1 reaction, 1. Unimolecular reaction. Unimolecular reaction means only the rate of reaction is dependent on any one concentration. That means reacting species, there are two, but only out of these two entities, one is going to play its role in the rate determining step. That means this reaction cannot take place in a single step. Why? Because two reacting species are there, two entities are being over there, but the rate of reaction is decided only by one. That means the second thing is missing in that rate determining step. That means this reaction will definitely take place in more than one step with the formation of intermediate. Now, once the intermediate is formed, then definitely the intermediate will have choice whether it can undergo rearrangement. If the ring is there, it can show ring expansion. Number of things are there, they can show, right? Let me check it out once again. So kids, let me see. Okay, this one is working. See, I've got one fundamental thing. Let me write down with this. Okay, it's working. So SN1, that is not working, but this is working. Let's move with this unimolecular. See kids, when you try your all the best efforts, then you will get some way. First of all, do let me know that Baba is really trying his all the efforts since this evening or not. Kids, do let me know. Sometimes this board is not working, sometimes audio. See kids, Baba is putting his all the efforts or not. So SN1, unimolecular nucleophilic substitution reaction. That indicates it follows first order chemical kinetics. That means there is one reactant, there is one nucleophile, they are going to give you product. But if I say that rate is equal to K, with respect to reactant, its power is 1. But with respect to nucleophile, its power is 0. Nucleophile is powerless. That means in the rate determining step, nucleophile is not involved. That means rate is independent of concentration of nucleophile. That means nucleophile is not involved in RDS, in rate determining step. It's not involved in RDS. So that means nucleophile must be involved in some other steps, but writing is visible. Writing is okay, kids, because I am not able to get this access. So writing, can you see? Writing is okay, kids. Let me check it out in the comment section. Writing is okay, kids. Vijay Kumar, what are you saying? They didn't started from basics. Vijay Kumar, what happened? Perfect. Okay. Now see, kids. Okay, this is gone. Then it's not working. Now that means, kids, if I say that I'm having reaction in this reaction, more than one step will be involved. And this reaction will proceed with intermediate carbocation formation. And rate of reaction will be directly proportional stability of carbocation, stability of carbocation. This is very important point to be noted, my lord, my all dear students, that rate of reaction is directly proportional to the stability of carbocation. Is everyone there? Now let me tell you, my dear students, if the rate of reaction is directly proportional to the stability of carbocation, so let me take one example, and before telling you each and everything, gets now even the after this board, okay, now let me check, is everything is going to be on right path? Now am I audible and visible? In between there was a lag, kids. Now is it okay? See, today what's happening, I can't understand. Now see, kids, let me take example number 1. Example number 1. hydrolysis of plus water, or it can be given as KOH aqueous. Hydrolysis of tertiary butyl bromide in basic medium, it could be like this. Now see kids, this is the reactant and what should be the product? Let me write down the product. Product will be like this: CH3, COH, CH3, CH3 plus KBr plus water. Now how the reaction, you must have seen CID serial that something is going to happen, and then after once that has happened, they are going to find out how it could have happened, in what way the things are moving. Just see the mechanism. Baba is going to tell you the mechanism of this reaction, and I hope that everyone is ready for the mechanism. Is everyone ready for the mechanism? Do let me know that everyone is ready for the mechanism, kids. Do let me know. Yes, are you ready for the mechanism? Mechanism. In this mechanism, step number 1 is formation of, that is the first step, formation of carbocation. Formation of carbocation. My dear students, just see to it. This was our reactant. Now you know very well, when you add rajma, you know rajma, kidney bean, you add kidney bean to the water and the whole night let it, that kidney bean over there, the kidney bean will swell up. That means if you add kidney bean, that is rajma, to the water and take it out, nothing will happen to that rajma kidney bean. But if you keep it for longer period of time, that will swell up, because water says, I will enter inside you and I will weaken your electrostatic force of attraction. So whatever the water is going to do, it will do slowly. So this step is slowest step, and here water is acting as solvent. Which solvent is acting as PPS, polar protic solvent, and this water will remove this bromide in the form of ion and it will form carbocation. Now carbocation, you know my dear friends, carbocation, carbon is having just 6 electrons in the outermost orbit, only 6 electrons. So it is crying for the electron. Only 6 electrons, only 6 electrons in valence shell, my dear friends, only 6 electrons in valence shell. That means it is highly unstable. So the equilibrium will go more on the backward direction and less in the forward direction, more in the backward direction. So this is slowest step, RDS. RDS means rate determining step. That is the slowest step. Everyone, are you getting it? This is having 8 electrons, so this is more stable, and more stable to less stable, that is not feasible process. This is step number 1. Always keep it in your brain. This is the carbocation, and carbocation is an intermediate, and how fast this rate determining step will proceed, that is going to determine the rate of reaction. Although it is being slow, but for other reaction in slow it can be fast. What is slow and fast? Means the slower step can be faster. So what do you mean by slower step can be faster? The one whose carbocation is more stable, so comparatively its slower step will be faster than other slower steps. In the slower step, that can be faster. I am not saying that is the first step. Everyone, are you able to get this point? So after this first step, just see the second step, everyone. See to it. That's step number 2, my dear students. Step number 2. This was the carbocation. Now in the carbocation, you know, my dear friend, one thing very clearly, that the pure p orbital is lying toward this side also and this side also. These are the two lobes of one pure p orbital. This is being your pure p orbital. Can you understand? Pure p orbital, unhybridized pure p orbital. Now the water will attack from this side also, but water is neutral, and KOH was like K positive, OH negative. So OH negative, who is a better nucleophile? OH negative. So OH negative will attack from the front side also, my dear friend. This is the front side. How to find out front side? The side from which the bromide has gone from the life of carbon plus. The side from which the bromide, the leaving group, has gone from the life of carbon is known as front side, and opposite to that, this is known as back side. This is the back side. Now both the sides are free, and never say in the carbocation there is steric hindrance, because carbocation is trigonal planar, and this carbon is saying, hey, how much OH negative you love me, come from the both side and form the bond. Now my dear friends, let me know one thing, that the bromide is having negative charge, electronic repulsion will be there. This is having negative charge. Due to electronic repulsion in between OH negative and this side attack will be less. I'm not saying that side attack will not be there, but due to electronic repulsion, front side attack will be less. In 99.9% cases. Why I am writing 99.9% cases? Because when the carbocation is highly stable, there will, when the carbocation is highly stable, there will be, when second, when the carbocation is highly stable, then in that case the leaving group must have gone too far away, then the chances of front side attack and the back side attack can be equal. Are you getting my point, kids? So I will say 99.9% cases, which attack is going to dominate? Back side attack is dominating. This is dominating attack, dominating. Kids, are you getting my point? This is the point where the examiner always asks question, that you have seen in SN2 reaction, only backside attack, 100% backside attack was there, but in SN1 reaction this is different, because here the attack is from the front side as well as from the back side. Both side attack is being taking place. Is it clear to all of you, kids? Is it clear? Both side attack. So both side attack will give you two types of product. Now let's see what are these two types of product. Now if I say the front side attack is less, minor, back side is going to be major. That means if I take about this carbon positive charge and 2,3-methyl, and this is being OH negative from the front side attack, this will give you CH3, OH. The side from the east side bromide has gone, same side OH is there. So this is known as retention of configuration, retention in configuration or off configuration. And I will say the backside attack is taking place like this: CH3, CH3, CH3 positive, and OH negative is going to attack from this side. So this will give you product like COH, CH3. In place of CH3 they can write amine, that is methyl, that is inversion of configuration. So both type of products has been formed. Now can you see, just a second, let me check it out what's happening, kids. Oh, memory card function. Kids, now am I visible, audible and visible to all of you kids? Now can you hear me, can you see me, kids? So this is clear to all of you kids. Now, so kids, let's study. But I think today lot of hurdles are there, right? But kids, from my side it is clear. Am I clear to all of you kids? Now, front side attack and back side attack both are possible. But if I take another example, that is, just see the racemization. Let me take another example, kids. The case number 2 or example number 2, racemization case. Just see to it. If I take this example where I have got chiral carbon, just see to it. Let me take once again racemization case. Just see to it, everyone. Bromide, CH3, ethyl, ET we can write, phenyl, PH we can write, and you can see very clearly this carbon is chiral. Chiral carbon. Can you see, kids? Chiral carbon. Now, if I reacted with C2H5OH, so definitely it is being weak nucleophile. Can you see it is being weak nucleophile? Everyone, can you see, kids? This is being weak nucleophile. So it will attack from the front side as well as it is going to attack from the back side. Clear, kids? This will come in the life of this carbon from the front side and it will also attack from the back side. So you are going to get two types of products. What are these two types of products? Let me tell you, let me draw these two types of products, my dear friends. Once OET, you will get OET here, ethyl over there only, here methyl, and this is phenyl. And in the second case, you will get OET at this place and inversion will take place. So Me and phenyl, you can see very clearly that this is chiral, and this is dextro and levo racemic mixture. So racemic mixture formation is there because these two are isomer of each other. If this is dextro, that is going to be levo. This is levo, that is going to be dextro. But my dear students, can you say they are equal? No. We can say this one is minor, this one is going to be minor, and that one is going to be major. Minor major combination, so that will remain because of enantiomeric axis. Can you understand? That is in axis amount because that is backside attack. So this will be in axis and this will left behind. So mixture is still optically active because suppose if it is formed 40% and that has been formed 60%, then 40 is in less amount. 40 will neutralize, will do the external compensation and will neutralize the another 41, the rest of the 20% that due to enantiomeric axis it will left behind. So what will you say? That racemization has taken place. This mixture is racemic but still optically active. Let me write down. This mixture is racemic. Racemic mixture is there. Racemic mixture is there but still optically active. Racemic as well as optically active. Everyone is able to understand? Do let me know if you are able to understand what I said, what I mean, kids. If everyone got it, do let me know that yes sir, it is very much clear to us. If everyone is able to understand. And let me tell you, my dear students, as the stability of carbocation will keep on increasing, the leaving group will go far away from this carbon slave and the chances of attack from the front side will keep on increasing. The chances of front side attack will keep on increasing. But the front side attack can never be more than back side attack. Means front side attack can be maximum 50%. In that case, we will say, yes, dextro and levo has been formed in equal amount and then there will be complete racemization. So I can say, my dear friends, what? I can say that extent of racemization, that is amount of racemization, we can say amount of racemization is directly proportional to stability of carbocation. Stability of carbocation. As the stability of carbocation will increase, as the stability of carbocation increases, front side attack will also increase. But can never be more than 50%. Right? In this case, we will say complete racemization. In case of 50-50, complete racemization will be there. If everyone is able to understand this point, because this point holds a hell lot of weightage, if everyone is able to understand, show me thumbs up or the fire in the chat section so that Baba can see some fire in the chat section that you are energetic. See, Baba is really working hard. Now, my dear students, after telling you this example, Baba is going to tell you that types of rearrangements. Okay. Types of rearrangements. Types of rearrangement. In this, first is 1,2 methyl shift. 1,2 methyl shift. Now, you see, whenever you are having some jacket during winter season, and if you feel too much cold, then your jackets will come down, will come over the head. But during summertime, not the summertime, but in winters, whenever their lunch time is there, sunrise is there, too much sun heat, then you will fold that jacket. This is known as rearrangement. When you are going to do rearrangement just to get stability, these will also do rearrangement for stability only. Rearrangement for stability. If they are getting stability, they will do rearrangement. If they are not getting stability, they will never do rearrangement. For example, if I draw compound like this, see, if I draw a compound like this, CH3, CH, CH3, CH positive, CH3. Now see, this is the carbocation, and if you talk about this carbocation, it is having 3 alpha hydrogen. This carbon is attached with this carbon, so this 3 alpha hydrogen, and this carbon is attached with this carbon, 1 alpha hydrogen. 1 and 3, 3 plus 1, 4 alpha hydrogen atoms. So it is stabilized by hyperconjugation SBH, and it is stabilized by inductive effect 2 degree SBI. SBI is not State Bank of India, but you see it is 2 degree. But in this compound, if this hydrogen is going to move at that place by taking its electrons, so it will go like this and it will come over here. Just see, it will look like this: CH3, C positive, CH3, CH2 and CH3. Has it got benefited? Just check it out. Is there any benefit? You see, it is attached with this carbon and that carbon. 3, 3, 6 and 2, 8. 3 plus 3 plus 2, 8 alpha hydrogen atoms. So it got benefited, stabilized by hyperconjugation and stabilized by inductive effect also, 3 degree carbocation. So this carbocation is more stable, so more formed, and this is less stable, so less formed. I'm not saying that only that is going to form. In between, number of molecules among I can say lakh crore molecules, some will convert into that and some will remain on this side, but these molecules will be more because they are more stable. So I can write what? More stable carbocation will be more formed. See to it what I am going to write: more stable carbocation more formed. More stable carbocation will be more formed. More responsible for major product formation, more responsible for product formation, and that is known as major product. I hope this much point is clear to all of you. This much everyone can understand. Now, if I say kids, less stable will be less formed and less stable will form minor product. Less stable will form minor product. Will form minor product. Now, simultaneously, if I say kids, I am having this carbocation CH3, CH3, CH3 and CH positive CH3. Now you can see this is less stable. How many alpha hydrogens it is having? 3, only 3 alpha hydrogen atoms. Now if this, on this carbon there is no hydrogen, if no hydrogen is there, So methyl will make a shift, will move from this carbon to that carbon, which is known as 1,2 methyl shift. 1,2 methyl shift. There was hydrogen, so 1,2 hydride shift, but here is no hydrogen, so we will say 1,2 methyl shift. And now see, it will become more stable. Just see to it. CH, CH3 and CH3. You see here only 3 alpha hydrogen atoms, but here 3, 3, 6 and 1, 7 alpha hydrogen atoms. So this is more stable, stabilized by hyperconjugation as well as stabilized by inductive effect, that is being 3 degree. Clear to all of you kids? More stable carbocation, more formed and more responsible for major product formation. If this much is clear to all of you, then I am going to tell you about the most important thing, that is ring expansion. So everyone is ready for the ring expansion, my dear students? Do let me know if everyone is ready for the ring expansion. Now see to it, the ring expansion. Baba is going to tell you about ring expansion, kids. That is really going to play very, very important role. Ring expansion. Just see to it. This is the ring. 5-membered ring, and this is carbocation. If I would have been the carpenter, then I must have broken this bond and nailed it here. It must have got converted to 6. But before that, let me tell you, 6-membered ring is highly stable than 5. 5 is approximately better than 7. The stability of rings. These are the stability of rings. Now, this is 5-membered ring, and 5-membered ring will try to convert into 6-membered ring. Now, I'm a chemistry teacher. I will tell you with the help of chemistry only that this carbon is going to withdraw electron, and that is going to be the loser. A transition state, highly unstable state is going to get formed, and that will look like this. See, this has got negative charge, that has got positive charge, this is having positive charge. Although this is highly unstable, so I'm going to tell you the bond is breaking from here and the bond is making over here, simultaneous breaking and making a bond, and sometime after some time this bond will get matured and it will look like this. See kids, it will look like this, and in this way 5-membered got converted into 6-membered. You can write like that, you can write like this, or you can write it like in the chair form like this. All are same, all being are same. Can you see kids? So let me know in the chat section that you are able to understand ring expansion. If you are not able to understand ring expansion, Baba will let you know again. But if you are able to understand ring expansion, show me some heart fire in the chat section that yes, Baba, we got it, we are able to understand. So I was worried about the, yeah, you got it. Now let me tell you in detail, kids. Remember that when the ring expansion will not take place, the cases where ring expansion will not take place, where ring expansion will not take place. Whenever the charge is on the ring, whenever the charge is on the ring, charge on the ring Second, whenever you are having this type of carbocation, this is highly stable, stabilized by dancing resonance. On the ring will not do ring expansion. This is adjacent to the ring, but this is adjacent to the ring, but what's happening, kids? This is stabilized by dancing resonance. Cyclopropyl is highly stable. Yeah, once again there was, yeah, lag was there once again, kids. Can't understand why it was like that, but yes, it was there. So now it's okay, kids. Yeah. So kids can't understand why it's happening. Now just check it out. Now is it okay, kids? Now is it okay, kids? Now okay. Now see to it. If I say, if I try to explain it, just see. If I write this cycle, just see to it. Can you see this cycle? Is it visible to all of you? Now, if I say these are the carbons, this carbon is there, this is carbon, that is also carbon. If this carbon is trying to withdraw electron, so it will develop negative charge and that will be the loser. So this carbon will try to form the bond with that carbon and simultaneously it is going to break this carbon's bond. And how it will look like? See, just see. It will look like this: CH2 partial negative, CH partial positive, and this is already positive. Just try to understand. Let me make it more clear, kids. This bond is breaking and simultaneously that bond is getting formed. Let me change the color. This bond is newly formed and this bond is going to get deformed. So this carbon is going to transfer its electron to that carbon. Just see what is going to happen. Now let me show you that actually is not possible, but let me make it so that you can understand. Just for understanding, let me make it like this: positive, this is having negative, and that is having positive. Now you know plus 1 minus 1 will become neutral. Plus 1 minus 1 will become neutral. So this is minus 1, that is plus 1. This will form the bond and they will become neutral. So you will get bond like this. This is the newly formed bond. 5-membered ring. Can you see, kids? This is 5-membered ring. Everyone can see to it. Are you able to understand, kids? Now you got it. Everyone got it. Just to let me know in the chat section, kids. Everyone got it? Yes. Now see, kids, I'm going to give you one question and I'm going to explain it in this way. The 4-membered ring got converted into 4-membered ring has been converted into 5-membered ring. 4-membered ring got converted to 5-membered. Now see, kids, just see. Let me take one wonderful example of SN1 reaction. Just see to it. Best example of rearrangement. Best example of rearrangement reaction. Just see. If I give you one reactant like this, and if I give you one reagent like this and another reagent like this, and examiner is asking find out the major product in both the two cases. You are required to find out major product in both the two cases. Let's see, kids. Right now you can see this is 5-membered ring. Everyone, five-membered ring wants to convert into 6-membered ring. But kids, those who don't know that C2H5 is a strong base, so definitely they will form 6-membered ring. But remember that this is being a strong base, this is going to form single step reaction, and single step reaction, no intermediate, so the product will be SN2, follow SN2 mechanism, and no ring expansion will be there, just inversion of configuration will be there, and 5-membered reactant will remain 5-membered only. No need to convert it into 6-membered. Kids, are you able to understand it? 1, 2, 3, and 4. But here you can see this is being weak base. Now weak base definitely will form carbocation, and once the carbocation has been formed, here this carbocation will say that always think about rearrangement. Carbocation formation, whenever there is carbocation formation, always think about rearrangement. So the 5-membered ring will immediately convert into 6-membered ring like this, negative charge and positive charge. This will form a bond over here. So you will get 5-membered ring converted into 6-membered ring, and this is the plus charge at this place. But my dear friend, the 5-membered ring got converted into 6-membered ring, but one more thing, special thing is going to happen. See, this is asking for hydride shift. Which hydride shift? This hydride. It is saying I am stable. I got converted from 5-membered ring to 6-membered ring, but I want to get more stability. This 6-membered ring, it is saying that carbon, please transfer your hydride from this place to this place, then I will become 5-membered as well as 3-degree carbocation. Then I will enjoy my all stability. So if I say this was the carbocation X, this is the carbocation Y, this is the carbocation Z. So definitely this carbocation 3, then 2, then 2, 2, 2, 4, 3, 7 alpha hydrogen atoms is going to be the most stable carbocation. But definitely this is carbocation. It has to form a bond to get a stability to destroy its charge. It will react with C2H5OH and it will form major product, and that major product will be like this. So if you are not able to understand, do let me know. I will explain again. I will explain 100 times if you are not able to understand. But if you are able to understand, then do let me know. This is the major product. Let me check it out and let me have a sip of water also, kids. Do let me know. Is everyone able to understand? If everyone is able to understand, do let me know. Show me some hearts if you got it. Very good, very good. Everyone is able to understand. That's really fantastic. Now, Baba is going to tell you after this. Baba is going to tell you the application of this, application of NSR from the NCERT. Okay, application of NSR. Are you ready for that, kids? to understand application of NSR? Very, very important. Very, very important. First is Williamson synthesis of ether. Williamson synthesis of ether. What Williamson said? Williamson said, take Rx, but remember that Rx should be either 1 degree or 2 degree, but never be 3 degree, plus sodium or potassium salt of alkoxide, sodium or potassium alkoxide in presence of dry ether. Dry ether is what? Dry ether is polar aprotic solvent. Polar aprotic solvent. So you have taken Rx. Now along with Rx you have to take R dash ONA or R dash OK. What product you are going to get? That product will be R O R dash ether you will get, and the whole summary I have told you, this reaction has to proceed with SN2 mechanism. SN2 mechanism. But this reaction is not that easy. To understand it completely, let me tell you some important points, then I will give you one question. Okay, first of all let me give you one example, simple example. If I say that we are having CH3Br plus I'm having CH3 CH2 ONA, so definitely I will get product as C2H5O CH3. So definitely you can answer this question if anyone is going to ask in your board examination or wherever they are going to ask. But I'm going to tell you the most important thing that will definitely change your life, my dear students. Just see to it. What Baba is going to tell you. Some important points which holds really 20% of organic chemistry moves with these points. Now, before telling you these points, let me draw something. Just do let me know what is this. Any ship, if you see any ship, Titanic ship, you can talk about Titanic ship, then there are three types of people. What are three types of people? One is captain of the ship. What is special about captain of the ship? He is strongly bonded with the ship. Not going to leave the ship easily. Will not leave ship easily. Am I right? This is the first person. Always ship is going to move with this person only. And in our organic chemistry, the ship is carbon. I will tell you, I will explain a carbon ship. Now, second type of people are rat of the ship. Most easily means good leaving groups. Good leaving group means will leave the ship easily. And the third category is like us, normal people. Third is normal people, normal leaving groups. If you are able to understand these three type of people, your chemistry is going to rock, kids. Now, should I tell you these three type of people in the organic chemistry, how to correlate these three type of people in the organic chemistry? Is everyone ready? Just see. So I said captain of the ship. Who is that captain in our organic chemistry? Captain is vinylic atom. Who is being vinylic atom? Vinylic atom is any atom non-metal directly attached to olefinic carbon, directly attached to olefinic carbon. What is olefinic carbon, kids? This is olefinic carbon. This is vinylic atom. So suppose if I say I've got compound like this, so all these atoms are vinylic. This atom is vinylic, this atom is vinylic, this atom is vinylic, this atom is vinylic. All these are being vinylic. This is vinylic, this is vinylic. All of them are vinylic. Now another one is arylic, which is attached with aromatic like benzene. So see, if I say this chlorine is there, this is arylic, R for Ritik, arylic. So these are poor leaving groups. They are strongly bonded with the ship. They are strongly bonded with the carbon. Everyone, is this point clear to all of you? Vinylic atom is clear to all of you. Arylic atom is clear. Now, after this, I am going to tell you allylic and benzylic. Then you will forget about these two carbons. So just try to keep it in your brain that yes, we have got it. We have got it. We have got it. Everyone got it, kids? Now see. Baba is going to tell you about allylic. Now, who are being allylic? Allylic means, according to me, rat of the ship. Rat of ship means very loosely bonded. Very, very loosely bonded. Now, let me show you. Allylic atom is an atom attached with sp3 hybridized carbon adjacent to olefinic carbon. Olefinic carbon. What's that? Just see to it. If I say this is the compound and there is bromine, there is chlorine, there is iodine, this is hydrogen, hydrogen. Chlorine is what? Chlorine is vinylic, iodine is vinylic, but this bromine is attached to sp3 hybridized. They were attached to sp2 hybridized carbon. So they were vinylic, but bromine is allylic. Very good leaving group. So don't think that iodine is very good leaving group. Definitely iodine can be very good leaving group, but if they are attached with the same carbon. But don't think about the atom, just think about the place. Place is being more important than the type of atom. Okay, so this is being allylic. Now, if I ask you kids, one more thing, this is being benzylic, this is also rat. Suppose if I say this is chlorine, this is bromine, and here this is iodine. So you see, just see to it, this is vinylic, no sorry, arylic, this is being not vinylic, this is being arylic, captain of the ship. This is also being arylic, captain of the ship. but this is attached to sp3, so this is benzylic, rat of the ship. Now you must have got confused by listening number of things. You must have got confused. So that you should not get confused, let me write down all these things at a single place. So what Baba is saying, captain. When Baba is saying captain, then chemistry says captain. What chemistry says? Chemistry says two things: vinylic and arylic. When Baba says rat of the ship, and chemistry says two things: one is allylic, one is benzylic. Now I hope it's clear to all of you that these two are poor leaving groups, means strongly bonded. So poor leaving group means will not leave that carbon easily, poor leaving groups, and these two are being good leaving groups. Now on the behalf of this, if anyone is going to give you, now you will ask, sir, why? What's the reason behind it? How many of you are interested to find out the reason behind it, why it is like this? So let me give you reason first, because you are having great mind, so you will be in need of reason. Just see to it the reasons Baba is going to tell you. Suppose we are provided with this compound, and according to whatever I have told you, you can arrange them in the decreasing order of reactivity. Definitely you can arrange them. Just see, 3 chlorines I am writing. I have written 3 chlorines. If you just try to find out, this is rat, that is normal, that is captain of the ship. So this is good leaving group, chlorine. This is normal leaving group, and this is poor leaving group. Just try to find out. This is your benzylic chlorine. Benzylic chlorine, if you see, this is normal, and this is being arylic chlorine. Can you see it's arylic? Till now it is clear to all of you. Now see, if this is going to leave, it will develop positive charge, and that charge will get resonance stabilized. So it is saying, hey, just if you want to go, just leave right now. I'm not going to get any problem. I will do resonance. But if this chlorine wants to leave, if this chlorine wants to leave, it is with this lone pair, and lone pair is involved in resonance. So the single bond is having partial double bond character. The single bond is having partial double bond character, so that cannot move, my dear student, that cannot move. It's like this, and due to resonance, the bond length decreases by 8 picometer. It is given in NCERT. Due to resonance, bond length decreases by 8 picometer. Bond length decreases by 8 picometer, and this single bond is having partial ionic character. Single bond with partial ionic character, kids. Single bond with partial ionic character. So if I compare them with the help of chemical bonding, I will say its bond order is less than 1. Bond order exactly 1, pure covalent bond, and its bond order is greater than 1. So if I either compare rate of SN1 reaction or I compare rate of SN2 reaction, then this is going to be the order. If everyone, is it clear to all of you? Then show me the green signal so that I can understand that yes, my dear students, you are getting it. Everyone, do let me know, kids. If everyone is able to understand, do let me know. I want to see in the chat section that yes, all my dear students getting it. Everyone You are able to understand it, kids? Do let me know. Yes, kids. Yes, kids. Wow. Where is Baba? Baba is here. Baba is here. I was checking. Everyone got it, kids? Everyone got it? Okay. Now see. This point is clear. Then first of all, do let me know. Let me ask question whether it's clear or not. Find out allylic, benzylic, arylic, vinylic. So if I write down one compound like this, and if I mark this chlorine is what I'm marking it to be arylic. You have to say right or wrong. Arylic, right or wrong. This hydrogen is benzylic, right or wrong. This hydrogen is vinylic, right or wrong. This hydrogen is vinylic, right or wrong. So, is this clear to all of you, my dear students? All these points are clear to all of you kids. Do let me know. Everyone is able to understand or not. I want to see in the chat section if it is clear. Do let me know, kids, that yes, it's clear to all of you kids. So, sir, can we complete full chapter today? Yeah, I'm trying that. I'm trying for that. Nawab's World, thank you. Darshini, thank you. Thank you. Kids, thank you. Now see, kids. See to all of you. So see to it. Now, Baba is going to tell you the application. A question, because for what I have given you this, find out the product. This question has been asked. Find out product. So this question has been asked. There was double bond. They have placed bromine over here. They have placed iodine at that point. And they ask question like this. C2H5ONA in axis. C2H5ONA axis. And they have asked the product kits. They have given the options also. Let me write down the options. Option A, OC2H5. Place of OC2H5 I have written OET. OET. Option B, OET. iodine, option C, bromine, OET. Now D is none of these. None of these. Do let me know what answer you are going to get. Do let me know in the options which option do you think is most appropriate. Most appropriate. So let me see in the chat section which option what kids are going for. C. Everyone is going for C, and definitely your answer is 100% correct. That before this question, if I haven't told you what is captain of the ship, then definitely most of the students must have gone for A. But this is being captain of the ship, that is not going to react. So this is a really awesome question, and that's why I have told you each and every theory. Now after this, now application number 2, Baba is going to move with application number 2. Just see to it, application number 2. Second application of NSR. Reaction with KCN. Just remember that if you are going to react Rx with KCN, so the reagent is KCN. Reagent is being KCN, but how the product you are going to get RCN. I will say how we have got the product. Just see the mechanism. From the market you got KCN. That KCN reagent has broken down into K positive and Cn negative. Why it's like this? This bond is being ionic. Kids, remember that this bond is being ionic bond. An ionic bond will break like K positive and Cn negative. This is going to break like that, K positive, Cn negative, and carbon is having negative charge, nitrogen is having lone pair. Both can act as nucleophile. When both are having capability to act as nucleophile, but only one is acting as the donor site, this is known as ambidentate nucleophile. Ambidentate nucleophile. I hope that this is clear, but carbon is good donor and carbon-carbon bond is good. So good donor will donate electrons. So you got this compound as cyanide. So if the same reaction, if I am going to do with AgCN, you will get different product. Just see to it what product you are going to get with AgCN, my dear students. With AgCN, Rx plus AgCN will not give you cyanide, it will give you RNC, isocyanide, kids. Isocyanide. Now you will ask, why sir? Why it's like that? My dear student, just see, AgCN is the reagent. AgCN is the reagent, and if I talk about AgCN bonding, you will see to it AgCN, and this bond is having maximum covalent character, pseudo inert configuration Ag plus, copper, silver, gold, zinc, cadmium, Cu plus, Ag plus, Zn2 plus. They are having pseudo inert configuration, and due to that this bond is covalent bond. So this is not going to break. This is the reagent as well as attacking agent. As I have given you in the evening one example of banana. You buy banana from the market or you buy orange, you have to peel it, then you can eat. But if you buy grapes, just see, I have brought grapes also, kids. Two fruits I brought just to tell you, if you have grapes, then you have grapes as the reagent as well as attacking agent. No need to peel it. You have to eat like this only, kids. That means this is the reagent, this is the attacking agent, and over here only nitrogen is having donor site. So nitrogen is going to attack on this R positive, X negative. This nitrogen is going to attack. And that's why we have got R and C. Got it? Isocyanate. Kids, how was the example? I brought two fruits just to explain this thing. That banana, in case of banana was the reagent, just peel it, attacking agent you will get. But in case of grapes, that is the reagent as well as the attacking agent. Now, my dear students, these two things you got. Now, let me tell you application number 3. Third application. Rx plus KNO2. Now, in this case, you will get RO and double bond O, nitrite. Now, let's see why you got nitrite. KNO2, this is the reagent. It is like K positive, O and double bond O. You brought KNO2, that is CONO. CONO has broken down into ONO. Why? Because there is ionic bond. ONO. Now, ONO will do resonance. So, you will get resonating structure like this. Partial negative. Now, nitrogen and oxygen both having lone pair. But oxygen is having negative charge. So, oxygen is best donor. Best donor has formed bond with Rx. You got it? So, you got nitrite. NIT, nitrite. But if the same reaction is going to take place, AgNO2, just see how the reaction will take place. AgNO2, see, Rx plus AgNO2, you will get RNO2, nitroalkane. You will get nitroalkane, kids. See why? You got reagent, this reagent from the market, but Ag is forming covalent bond. So, it should be AgO and double bond O. You can see like this. This is the covalent bond having more covalent character. 100% now, nobody is covalent, nobody is ionic. Just see, oxygen is having lone pair, nitrogen is having lone pair, oxygen is having lone pair, but electronegativity of oxygen is 3.5 and its electronegativity is 3. So, this is good donor. So, this time it is going to donate electron. Everyone got it, kids? Till now, is it clear to each and everyone? Is everyone able to understand that why we got nitroalkane formation? Nitroalkane formation. Why we have got nitroalkane formation is point. This point is clear to each and everyone, my dear friends. Now see, if I say that halogen exchange, fourth application, halogen exchange reaction, halogen exchange reaction. In this category, two reactions are there. First reaction I would like to say, that is Finkelstein reaction. You must have heard the name Finkelstein reaction, my dear students. Finkelstein reaction. What is going to happen in Finkelstein reaction? Just see to it. Rx, where X can be either chloride or bromide, plus NaI triacetone, you will get Ri plus NaX in the form of precipitate. And once the precipitate is there, Le-Chatelier's principle is applicable. So, in this way, chloride and bromide can be converted into iodide. Is this point clear to all of you, my dear friends? Om Reddy, thank you, thank you. Now, another reaction after this, I'm going to tell you, that is Schwarz reaction. That is really very, very important reaction, kids. Schwarz reaction. So what's special about Schwarz reaction, my dear friends? Rx, here also X is equal to either chloride or bromide, is going to react with some specific metal fluorides, and those specific metal fluorides will convert this Rx into RF. But examiner will ask definitely these specific metal fluorides are what? What are these specific metal fluorides? Then, my dear students, remember that fluorides of antimony, cobalt, Ag, mercury. This is very, very important. How to remember it? That fluorides of antimony, cobalt, silver and mercury. Is there anyone who can make trick for this? Let me see in the chat section. Is there anyone who's going to make kit for this? No one is making kits. Do let me know. So see, this is anti, this is cobra, and this anti. When anti has seen cobra, he has done silver hugs to Florida. So cobra, silvery hugs, or antimony. It's anti. So you can remember it. Okay, my dear students. So anti, cobra, silvery hugs. Anti, okay. Cobra is doing silvery hugs to anti, or anti is doing silvery hugs to cobra. Anti and cobra, they are doing silver hugs, right? Is this point clear to all of you? And this is known as Schwarz reaction. Schwarz reaction. Is this point clear to all of you? Now, my dear friends, after this, I'm going to tell you very, very important thing. Let's see. That is Hoffman's alkylation. Hoffman's alkylation. Just see to it. If we are provided with Rx and ammonia, just see to it. This ammonia is having lone pair and this R is having delta positive. This ammonia will attack from the back side and it will do SN2 reaction. But if I go in depth with SN2 reaction, you won't be able to understand. So let's keep it simple. Simply how to deal with this reaction, because examiner will not ask the mechanism. So RCl, or I can take methyl so that better you can understand. If I take this to be the methyl, now, so RCl, let me take any R can be methyl or whatever. Now this is ammonia. Now what they are going to do, kids, they will form bond, HCl will eliminate out, then you will get 1 degree amine RNH2. Once again RX will come, RX, and once again HCl will get eliminated out, my dear students. HCl will get eliminated out, or HX will get eliminated out. You will get R2NH. Once again RX will come in its life and the reaction will be like this. HX will eliminate out and you will get 3 degree amine R3N, my dear students. Still the lone pair is there, and this once again will go and react with Rx, and now you will get quaternary ammonium salt. This is known as Hoffman's alkylation. This X will be over there. This is your quaternary ammonium salt. Got it, kids? Now how many times you got SN2 reaction? Once SN2 reaction, one more time SN2 reaction, one more time SN2 reaction, and finally one more time SN2 reaction. 4 times you got SN2 reaction, and this is Hoffman's alkylation. Is this point clear to all of you? My dear friends, now Baba is going to explain about ARSN2 reaction. Is everyone ready, kids? Is everyone ready? If yes, show me some fire in the chat section. So Baba is going to deal with ARSN2 reaction. Aromatic bimolecular nucleophilic substitution reaction. Aromatic bimolecular NSR. This type of reaction is common to very rare reaction. Very rare reaction and takes place only with halobenzenes. Only with halobenzenes. Now halobenzene is like this, kids. And very specific thing is that here fluorine can also be there. That either fluorobenzene, it can be either chlorobenzene, or it can be bromobenzene, or it can be iodobenzene. All they will react. And very important thing, the fluorine which was not reacting here, the maximum reactive is fluorobenzene only. Now you will say, sir, what happened to you? Why you're talking like this? That fluorobenzene is going to be most reactive. I will explain the mechanism and then you will understand why the reactivity order is like this. Number of students must be thinking, Baba, iodine is very good leaving group, then why you're talking like this, that fluorobenzene is going to be most reactive? How many of you are interested to know the mechanism of ARSN2? Let me explain the mechanism and the reaction. It is given on page number, in NCERT page number, old NCERT page number 303 and new NCERT page number 311. You can see NCERT, right? It's given like this, either 311 or 303, right? Let's see the mechanism, my dear students. So, mechanism and the reaction. Mechanism and reaction. The reaction is like this, which is given in your NCERT, that this is your benzene, chlorobenzene plus NaOH, and the reaction will not take place simply. So you have to apply 623 Kelvin and 300 atmospheric pressure in place of H plus, then it will form phenol. Phenol will be the answer. This reaction is known as Dow's process. Dow's process. Dow's, cow and doggies, hybrid Dow's you can say, and this follows addition elimination path. Addition elimination path. Mechanism. Now let's see to it how the reaction will proceed and what should be the mechanism. Is everyone ready, kids? Is everyone ready? Okay, now let's see how to do it, kids. So there is the mechanism. Mechanism is, this is our chlorobenzene, and chlorobenzene is strongly bonded with this benzene because this is being arylic. Its lone pair is having resonance with the benzene. OH negative is saying, I will attack on you, I will attack on you, but this chlorine is saying you can't do anything. So people have increased the temperature 623 Kelvin, and when you increase the temperature, molecules will go far away. So once they have increased the temperature and simultaneously they are increasing the pressure also, so the molecules cannot move anywhere. Molecules cannot move anywhere. So the pi bond will break. The pi bond will break and the electrons will shift toward this side. Why only toward this side? I will let you know. and this OH is going to attack on this carbon, because once the electrons are going toward this side, this will get negative charge and this will get positive charge. So the sidewise attack is there. Sidewise attack is there. It's neither SN1 nor SN2, neither SN1 nor SN2. It is sidewise attack. So this is different reaction. And what intermediate you are going to get, kids, just see to it. You will get negative charge at this place. This is your chlorine. This is your OH sidewise attack. And first time you are seeing that the intermediate is carbanion. Just see to it. First time you can see the intermediate is carbanion. This is really peculiar thing. Carbanion is the intermediate. Carbanion is intermediate first time. This is very, very important thing, kids. Carbanion is the intermediate. Now see, once the carbanion is the intermediate, it will do resonance. If I draw its actual structure, I will draw it on another page, but this is unstable because this was aromatic. This was aromatic and that has become non-aromatic. Don't say anti-aromatic. This carbon is sp3 hybridized, so non-planar. Non-planar means what? Non-planar is non-aromatic. Non-aromatic, kids. Non-planar is non-aromatic. Now see, this has been formed and that is unstable. This is being unstable because it is not aromatic. So definitely this equilibrium will go more in the backward direction and less in the forward direction. So this is a rate determining step and this is being the slowest step. Slowest step is always rate determining step, my dear friend. Is it clear to all of you? Are you getting my point? Is everyone able to understand this point? Now see, the second step will be fast step, because in the second step, Na plus will approach this chloride and this chloride's lone pair is now not doing resonance with the benzene because this carbon is sp3 hybridized. The chlorine, which single bond was having partial double bond character, this was the captain of the ship, or you can say this was arylic. Now the arylic has converted into allylic because this carbon is sp3 hybridized. This is allylic. The captain of the ship has become rat of the ship, that is being good leaving group. So very soon it is going to leave and it will take this electron. So this will develop partial, positive and negative. Once again, it will become benzene. Now, this is the first step. Now you will ask, sir, why NaOH has been added? This is acid. Now, if we are not going to add H plus, then the NaOH which is left, because you have used NaOH, that base will once again react with this to form sodium phenoxide. Just to neutralize excess of NaOH, we have to use H plus to neutralize left NaOH. Acid is being used. Now, I have told you the mechanism, but the point is not clear. Why the fluorine is best reactive or maximum reactive, and why the temperature has been used. Number of factors are there. So let me clear it. But if you're ready, let me have a sip of water. Show me some fire in the chat section that yes, Baba, we are ready. Yes, Baba, we are ready. At 12, I will give you one break. At 12, I will give you one break, right? And those who have not liked this session, kids, do like it. I need your likes. Baba needs your likes. Nawab's world, thank you. Thank you. Now, kids, let me move ahead. Let me move ahead, kids. So see to it. Factors affecting stability of carbanion. Factors affecting stability of carbon. Just see to it. Factors affecting stability of carbanion. After ARSN2, I will give you mind map kits for ARSN1, right? So see, first factor is resonance. How resonance is going to affect it, see to it. This is the true structure of that carbanion, negative charge at this place, negative charge at this place, negative charge at this place. So the charge is moving like this. This was your chlorine and this was your OH. Now, if you place any electron withdrawing group at orthopara with respect to this leaving group, if you place here NO2 group, any electron withdrawing group, then what this electron withdrawing group is going to do, this will make this electron to move over there also. So, this electron will do resonance on this group also. So, more delocalization, more resonance, more delocalization, more dispersal of the charge means less magnitude of charge, more will be the stability. So, charge will decrease, charge will decrease and stability will increase. Stability will increase. So, if you place NO2 group at this place also, if you place NO2 group at this place also, kids, any, I am not saying only NO2, any electron withdrawing group, that is minus M minus R, will do the same thing. If you place NO2 group here also, then maximum dispersal of the charge means more stability, more resonance, more will be the rate of reaction. Can you see? Maximum stabilization, by minus M group at orthopara position. Right, kids? You got it? Now, my dear students, just see to it. First point is very much clear to you. Now, I am going to tell you the another point, that is fluorine 1. How, second point is inductive effect, how minus I effect increases rate of reaction. Just see to it. This was the carbanion and there was the halogen. You see, halogen's lone pair cannot do resonance, but it can apply minus I. It is withdrawing electron, and this minus I effect is stabilizing the charge. That means carbanion stability is directly proportional to minus I and inversely proportional to plus I. And who is having maximum minus I? Fluorine is having maximum minus I, then chlorine, then bromine, then iodine. This is the difference, electronegativity difference, because fluorine's electronegativity is 4.0 and this is just 3.19 only. So this is if fluorine is stabilizing maximum, and that's why in the NCERT 4 reactions have been mentioned. Let me tell you those 4 reactions. These 4 reactions are like this. See to it, kids. 4 main reactions. One was given like this: chlorobenzene plus NaOH. The temperature was required as 623 Kelvin, 300 atmosphere. H plus It was giving you phenol. If I tell you the second reaction, if you place one NO2 at para position, now the same reaction will take place at how much? 400 and something 50 Kelvin temperature only. You will get nitrophenol, para-nitrophenol. If you carry out reaction with this two NO2s, now only the temperature will required will be 369 Kelvin, kids, only 369 Kelvin, and you will get 2,4-dinitrophenol. Now they are saying that if you carry out the reaction with this compound with 3 NO2s, another page, please turn over the page in your NCERT, then no need to take NaOH. Even if you do this reaction with boiling water, that will be better and you will get picric acid. Just check your NCERT and you will get it like this on. These are the 4 reactions and you can understand these 4 reactions very easily, kids. Whatever I taught you, these reactions are based on that, and definitely they are going to play very important role. Now after this, Baba is going to give you the memory chart for ARSN1, mind-blowing chart, and number of questions will come from that memory chart. Is everyone ready? Say yes. Show me some fire in the chat section. Then Baba is going to give you that memory chart, kids. Baba is going to give you that memory chart. See. So, mind map you can say, memory chart you can say, for ARSN1 reaction. Just see to it. Let me make that chart. Here is your benzene. And if you do reaction of benzene with concentrated HNO3, concentrated H2SO4, you will get nitrobenzene, kids. Now, if you do the reduction of nitrobenzene with tin or iron HCl, you will get aniline. Now, if you do the reaction of aniline with NaNO2 HCl, ice cold solution, 0 to 5 degrees Celsius, then you will get benzene diazonium chloride. Benzene diazonium chloride. Now this benzene diazonium chloride, if you react it with boiling water, that is H2O heat, you will get phenol. And if you react this phenol with the zinc dust, you will get benzene. Now, you can directly convert this benzene diazonium chloride into benzene by redox reaction. What is that redox reaction, kids? If you take phosphinic acid, that is H3PO2, that will undergo oxidation to give H3PO3. and this benzene diazoxide chloride will convert into benzene, or in place of that you can use ethyl alcohol. Ethyl alcohol will undergo oxidation to acetaldehyde, and this will get converted into this. Now benzene diazoxide chloride's Bal-Schimann reaction. Bals you will get once again chlorobenzene, but yield is less. The name of this reaction is Gutterman reaction. Gutterman reaction. It's, if I say that if you react this benzene diazoxide chloride with CuCN, KCN, you will get benzonitrile, benzonitrile, C triple bond N, benzonitrile. This is also Sandmeyer reaction. How is the memory chart gets? Do let me know. Are you liking this memory chart? Everyone do let me know, my dear students. Let me see in the chat section. Let me see in the chat section, everyone is enjoying this memory chart or not. So many questions will come from here only, gets maximum questions will come from this. Now, my dear students, till now I have told you all about substitution. Now, after the break, I am going to tell you about elimination, because this chapter is fully based on substitution and elimination. So, this is all about substitution. Baba has completed. Now, it will take for elimination. So, is everyone ready? I'm going to give you a short break, and then after the break, Baba will continue with the elimination part. Okay? After the short break, Baba is going to deal with elimination part. So, it's a short break. Let's meet at right now it's 7:45. So 12:05. Okay. 12:05 means next day, tomorrow. Is it okay, kids? Will you come with the same energy? Let's have something. Okay, fantastic, fantastic. Hey everyone, welcome back. Are you ready? We are going to start with elimination. How's the Josh? Do let me know, all my dear students. Is Baba audible as well as visible to all of you? Show me the green signal if yes. Let me check it out that everyone is awake. The red signal, green signal, whatever the signal you can show, you have to show it. The fire in the chat section, or the green hearts, or the whatever the red hearts. Yes, it's everyone. Do let me know, is Baba audible and visible? Yes, that's really fantastic. So we are going to start with elimination. Elimination, my dear students. Before moving towards this elimination reaction, okay, questions we will do at the last. Okay, all the questions we will do at the last. Or right now, before elimination, would you like to do some questions? I want to see in the chat section. At the last, you want to do questions, or just before the elimination, you would like to do some questions? Do let me know, kids. Everyone, do let me know. Questions, yeah. Everyone is saying questions. So let's see. Questions time. What type of questions they will ask? So they will ask question like this, that there is benzene has undergone reaction with concentrated HNO3, concentrated H2SO4, has given A has been treated with twin HCl, has given B, that has been treated with NaNO2 HCl. They can give you NaNO2 HCl because this together will combine, give you HNO2, that will break to give you NO plus, nitrosonium ion. So whatever they can give you, you have to follow it. Has given C, and C reacted with cuprous chloride Cu2Cl2 HCl. They can give you like this. Has given D, and D has been treated with NaOH. NaOH has given E, and E has been treated with zinc dust. So what is your F? You're supposed to find out F. Do it. Let's see whether you are able to do it. Do let me know in the chat section what's your answer. If your answer is moving in this way, that concentrate HNO3, concentrate H2SO4, you will get nitrobenzene, then you are on the right track. Then aniline, once again you got it. Now after aniline, if you have got benzene disonium chloride, then really best. And once benzene disonium chloride, this is being Sandmeyer reaction. After that, we have got chlorobenzene, then really awesome. This is being Dawes process. Dawes process, you have got phenol, and after phenol, zinc dust. So ultimately, we have returned back to benzene. How many of you have got this correct answer? If your answer is correct, then show me the green signal in the chat section. If your answer is found to be wrong, then yes, fire. Either hearts or the fire. Let me check it out, what you are going to get. Yes, kids. Now, let me give you one more fundamental thing to you, that if you get anywhere, one more mind map, so that you can do all the questions, that whenever you are provided with benzene disonium chloride reacted with CuCN, KCN, you will get cyanobenzene, And cyanobenzene is very, very, really awesome thing that once you are going to react this cyanobenzene with water in acidic medium, you will get benzoic acid. When you react cyanobenzene with H2O2 OH negative, you will get benzamide. And if you react benzamide with H3PO4, water will get eliminated out. Once again, you will get it back. If you react this with SnCl to HCl, you will get amine. You will get amine, and amine is unstable. So if you react this amine with water in acidic medium, you will get benzaldehyde. And the name of this reaction is Stephen's reduction. Stephen's reduction kits. Now, if you react this cyanobenzene with sodium amalgam ethyl alcohol, then you will get benzylamine. The name of this reaction is Mende's reduction. So this is another awesome memory chart kits. If you're liking it, do let me know, and let me tell you, this benzene diazonium chloride you got from which thing? You got it from aniline. And aniline, remember that either they are giving you HONO, that is HNO2, nitrous acid, or they are giving you NO plus nitrosonium ion. Whatever they are giving you, you have to form benzene diazonium chloride. This is really going to help you a lot, my dear friends. So one more question I am going to give you on the basis of this. Just see to it and let's see whether you are able to answer it or not. The question will be given like this: find Z, how the reaction is going to proceed. They have given compound like this, that you are provided with chlorine. They have done the reaction with NaOH, you got A. Then they have done the reaction with zinc, you got B. Then they have done the nitration, you got C. Then they have done the reaction with iron HCl, you have got D. Then they have done the reaction with nitrous acid, you got E. Then they have done the reaction with HbF4 heat, you got F. Then they have reacted with NaOH, high temperature and pressure, in presence of H plus, you got G. What is G? Find out G. What is G? Let me see. It's really fantastic. Om ready. Okay, no problem. Om ready. Rest of other students, do let me know what you're going to get. What's your answer? Then I will start elimination. So chlorobenzene, this is being Dawes process. After going through Dawes process, you will get phenol on reaction with zinc dust, you will get benzene, my dear friends. Benzene nitration, you are going to get nitrobenzene. You are going to get aniline. Now this nitrous acid, you will get benzene diazonium chloride. Now this is Bal-Schimann reaction. You will get fluorobenzene, and once Dow's process you will get phenol. I hope everyone got the correct answer. If your answer is being found to be correct, then do let me know that yes, show me hearts, otherwise fire in the chat section so that I can move ahead and I can tell you rest of the other things, my dear students. Now elimination, I am going to consider elimination. Just see to it. Elimination. Elimination is mainly of two types: alpha elimination that is also known as 1-1 elimination, the second is being beta elimination. That is 1-2 elimination. It's alpha elimination and beta elimination I am going to tell you in detail, but first of all I would like to see that most of the students, they are feeling sleepy, or you are ready kids. Do let me know. Baba is going to deal with alpha elimination and beta elimination. What happened to your promise? Kids, let me see in the chat section what kids are writing. Are you ready? Darshani is right, ready. Vardhan is ready. Okay, my dear students, all my dear students, they are ready. So what to say? All my hard-working HSP and army is ready. Then no need to worry. Okay, you my kids are ready. Then no need to worry. So Baba is going to start. Okay, kids, that's fantastic. Darshani is there. Rest of all my dear students are there. Let's see. Let me start with alpha elimination. I will start with alpha elimination. There is only one example of alpha elimination. Let's see alpha elimination's best example and why it is known as alpha elimination. That also I am going to tell you. This is chloroform CH, Cl, Cl, Cl. When it is reacting with the strong base like KOH and heat, alcoholic KOH is elimination indication. That C, the carbon which is attached with halogen is known as alpha carbon or first carbon. You can say first carbon or alpha carbon. This base OH negative is interested in proton. It will take its proton, so definitely it will get negative charge. It will form water. Now once the negative charge is on carbon, just see it is stabilized by back bonding. That's why it has donated its proton, and that proton is now known as acidic H, acidic hydrogen. Now once it got negative charge, it will do back bonding. This is 2p pi electron and its 3d is vacant, so it's stabilized by, this is being stabilized by 2p pi 3d pi back bonding. Now after all it is having negative charge, so K plus will come and K plus will take this chloride. So see kids, first carbon has lost hydrogen as well as halogen. It has lost 2 atoms. So alpha carbon has lost 2 atoms. That's why it is known as alpha elimination, or you can say 1-1 elimination, because both the 2 atoms has been lost from 1 carbon. So it will give you CCl2. Now CCl2 is looking like nucleophile because you can see it is having lone pair. But kids, it is not nucleophile. It is having just 6 electrons. So it is being electrophile, only 6 electron. This electrophile will be responsible for 2 name reactions. What are those 2 name reactions? It will be responsible for carbylamine reaction and second Reamer-Tiemann reaction. Reamer-Tiemann reaction. It will be responsible for these two main reactions. Now, this was the only example of alpha elimination. Now, we are going to deal with beta elimination, and beta elimination we have to see in detail. This is the main focus point. Beta elimination is very, very important. So, are you ready for beta elimination, kids? Is everyone ready for beta elimination? Beta elimination is like this. This is carbon, this is carbon, this is halogen, this is being hydrogen, rest of the two valencies. Now see to it, K plus will come and it will take this X and OH negative will come. This is take this proton, so this will develop negative charge and this will develop positive charge. Where is halogen? This is known as alpha carbon and this is known as beta carbon. One atom has been lost from alpha, another being from beta, and they will form bonds. So it will finally look like this, double bond. Now KX plus water. So kids, this beta elimination will be of two types. One is E2 and another one is E1. First I will start with E2. So I want to see that all my dear students are ready. So let me divide this beta elimination into two categories. That one is being E2 reaction, another one is being E1 reaction, my dear students. E2 and E1. As in the starting, I've told you the story and we are going to move through that story, my dear students. Okay, so let's see. First of all, let me start E2 reaction. E2 reaction. E2 reaction follows single step mechanism. And let me tell you, the most important thing is that E2 reaction is going to follow anti-periplelar mechanism. E2 reaction is following anti-periplanar mechanism. Anti-periplanar mechanism. And this is the most important question for competitive exam. What is anti-periplanar mechanism? Because this puts a hell lot of weightage. Most of the examiners, they are going to ask question based on this. What is anti-periplanar mechanism? So let's see what is this anti-periplanar mechanism. If I say that the meaning of anti-periplanar mechanism is that I am provided with compound like this, and this is the halogen coming towards your side, towards observer side, that is chlorine. Now, if I say that this methyl is coming towards observer side, that means if the methyl is coming towards observer side, then its hydrogen is going away from the observer. Now, if I say here the ethyl is going away from the observer, then I will say its hydrogen is coming towards observer side, because two valencies will be in the plane of paper, one going towards observer side, one is going away from observer side. So anti-periplanar mechanism means this is the halogen having delta positive charge polar bond. This is alpha carbon, this is beta, and this is beta. From beta, the thing which eliminate out will be opposite of it. This is towards observer. If this is lying towards observer, so this hydrogen is going away from observer, it will go from here. That means this chloride and this hydrogen will eliminate out. So the product formed will be like this. Now kids, You must be thinking, sir, I'm so unable to understand what has happened. I can't get it. What has happened? Let me explain with another example, then you will come to know that what actually has happened. See another example. Second example, Baba is going to give you second example. Just see, if I give you this compound and if I say that chlorine is coming towards observer side, chlorine is coming towards observer side, and if I say this ethyl is going away from observer, that means its hydrogen is coming towards observer side. Yes. And if I say here deuterium is going away from observer, the isotope of hydrogen, and the methyl is coming towards observer side, who is anti? Who is being anti to this chlorine? This is coming towards your side. This chlorine is coming towards your side. This deuterium is going away. So definitely these two are anti to each other. This and this anti. So only this chlorine will go with this deuterium because this is anti and periplanar. So the product formed will be like this. I hope that now it is clear to you. Now you are able to understand it. The double bond will be over here. This is being ethyl. This is being ethyl. Now, if everyone is able to understand, Baba is going to give you one question, rank deciding question, and try to understand it and try to answer it. Then only I will say, yes, you got it. Okay. Question is, which will not show E2 reaction? Okay, which will not show E2 reaction. A is like this. Chlorine, 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 chlorine. B is like this. Chlorine, chlorine, chlorine. C is like this. Chlorine, 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 chlorine. Do let me know. Is there any answer out of these three? Let me draw D1 also. See, what's your answer? Do let me know. If you are able to understand, do let me know what's the answer. A. Everyone is going for A. Oh my God. This is coming towards your side. Then hydrogen. Yeah, correct. Absolutely correct. Kids, you are really very intelligent. I think you know the whole chemistry. You know already the whole chemistry. I'm thinking that way. Now, kids, Let's move ahead. The example of NCERT Baba is going to take. NCERT example Baba is going to take. NCERT example number 1. Okay. Just see to it that CH3, CH2, CHX, where X is equal to, not equal to fluorine, you can say not equal to fluorine, anything. Now CH3 is going to react with KOH, alcoholic, and heat. Now how many types of products will be formed? The question is, how many types of products will get formed? 1 type, 2 type, 3 type, or 4 types? How many types of products will get formed? Now let's see. This is your alpha carbon, this is your beta carbon, this is also your beta carbon. So X will go from here. Whenever the X is going, it will go as in the form of negative charge. There will be positive charge, and proton means simultaneous breaking of this sigma bond and that sigma bond. Are you getting my point? Simultaneous breaking. So one product you will get this one, CH3, CH, double bond CH, CH3. Another product you will get this type, CH3, CH2, CH, double bond CH2. Now remember that here, if I encircle this double bonded carbon, so how many alkyl groups are left? This is one alkyl group. This is another one. So I will say this is a disubstituted alkene. Disubstituted alkene. And if I place here double bond, this is monosubstituted alkene. Okay. Monosubstituted. Now my dear friends, this is more substituted alkene, and more substituted alkene is known as what? More substituted is known as SET-JEF product. Remember that SET-JEF, and another name for it, JET-SEP product. And this is being the major, 80%. This is the major, SET-JEF product is major. That is known as less substituted alkene. Less substituted is known as Hoffman product, and Hoffman product is minor. Now my dear students, according to you, there are 2 types of alkenes have been formed, and these 2 types of alkenes, they are structural isomers. Can you see these? What is the relation in between 2 types of alkenes? They are structural isomers. Now, one structural isomer is formed in major amount and another one is formed in minor amount. This type of fundamental thing, if we talk about with respect to chemistry, this is known as regioselective. Which word I am using, kids? Regioselective. So E2 reaction is regioselective. Let me write down this word on the another page. Regioselective. Regioselective. If I talk about selective, that if in your plate there is tomato rice and another plate you are having biryani, then definitely you will eat more biryani and less tomato rice. That means your selection, you are more selective towards biryani, and you are not liking that much of tomato rice. So selective for one thing major, one other thing minor, that you are consuming one thing in more amount, one thing is getting formed in major amount. So their word is used regioselective. Now see, this double bond is dead for Gi. Dead for Gi. Why it is dead? These 2 hydrogen atoms are same. It cannot show Gi, but this will show Gi. and this will show GI, it's then how it will look like. See, that butene, that is your set-J product, that is your set-J product, will exist in two forms, that is one, transbutene, and this transbutene will be major product, then this cis-butene. Why kids? Because bulky groups are on opposite side and there the bulky groups are on same side. When the bulky groups on same side, so there is maximum repulsion. Now my dear students, let me tell you, these two are also isomer, but these two are stereoisomers. They are GI, and the relation is that they are stereoisomers. Now out of these two stereoisomers, one is formed in major amount, one is formed in minor amount. So the scientific word used for this is E2 reaction is stereoselective. Now, whatever we have studied till now, my dear friends, so I can write down in one single step. What is that? That E2 reaction is regio as well as stereoselective. And follows what? Anti-periplanar mechanism. Anti-periplanar mechanism. Anti-periplanar mechanism, my dear friends, it follows anti-periplanar mechanism. Now, what do you think? That in this reaction, always set-J product will be major. Let me tell you some examples where Hoffman product can be major. So after this, let me show you some special cases. Of E2 reaction. Where Hoffman product can be major. Just see the first reaction, first case number 1. Case number 1, kids. When fluorine is leaving group. When fluorine is leaving group. Just see, kids, why and how. CH3, CH2, CHF, CH3 plus KOH, alcoholic heat. Now in this case, this product which is known as set-J will be minor. This is your set-J product, more stable product, but then also minor, only 20% minor. even though it is stable, but then also it will form in less amount. And Hoffman product, that is less stable, but then also it will form in major amount. Now let's see the reason behind it. The leaving group is fluorine, then I am talking about this is going to happen. This will happen when the leaving group is fluorine. So everyone is interested to understand why it is going to happen. It's in this way, what mechanism it is going to follow. Now see kids. Reason and mechanism. CH3, CH2, CH, fluorine, CH3. You see this bond is very strong bond. Why this bond is very strong bond? 2p and 2p. 2p bond is being very strong bond kids. This is not going to break easily. So the OH negative will come and approach on this hydrogen. OH negative will come and will approach on this hydrogen. Why only these hydrogens? Because this is being alpha, they are in beta. Beta hydrogen only going to move. When the OH negative is going to approach, just see what you are going to get. You will get compound like this, CH3, CH, delta negative, and this hydrogen will start moving towards OH, CHF, CH2, H, this get negative charge, and this H plus will start moving with OH negative. Just see to it kids. This negative charge is 2 degree, this carbon ion is being 2 degree, and that carbon ion is 1 degree. Who is being more stable? Then you will come to know that 2 degree is less stable and 1 degree is being more stable. Are you getting my point kids? This is being more stable. Now this is not actually carbon ion, this is the partial negative charge in transition state. This because in E2 reaction intermediate will never get formed. I cannot say this is being intermediate. This is the transition state, and this is not carbon ion, this is partial negative charge. The word I will use, partial negative charge. So that is more stable, and more stable will get more formed, more responsible for more product formation. So in this reaction, my dear friends, stability of product doesn't matter. What matters, that is partial negative charge in transition state. More is the stability of partial negative charge in transition state, more it will get responsible for product formation. Why this is happening? This fluorine is not going to leave. Otherwise, in the earlier reaction, there was simultaneous breaking of 2 sigma bonds and making of 1 pi bond. But here in this case, only the breaking of this sigma bond. Here it is not going to move. But after some time, they will give electron toward this side, then repulsion between fluorine electrons and these electrons. Later on, fluorine will also leave. But my dear friends, before that, you have to understand what? That in this reaction, rate of reaction is directly proportional to stability of partial negative charge in transition state. We have not to see the stability of product, we have to see just this thing. So definitely I've told you. Now in many books only one example is given, and this is this one. So people start thinking that always Hoffman product will be major when fluorine is given to be the leaving group, but that is not true. Let me give you another example. So that's why Little knowledge is always dangerous thing. Fluorine, when fluorine is leaving group, second example I am going to give you. Example number 2. Just see to this example, my dear friends. If I draw this compound, now see, this will form carbonyl, that will form carbonyl. Definitely this carbonyl is 1 degree and this is being 2 degree. But whenever the resonance takes place, degree doesn't work. Degree has no meaning where resonance is taking place. So this carbonyl is stabilized by resonance, even though it is 2 degree, but is stabilized by resonance. So this carbonyl is more stable, more formed, more responsible for major product formation. So this is your alpha, this is your beta, this is also your beta. So see which product you will get as the major. Once again you will get Hoffman product as your major product, gets more substituted. No, sorry, ZJ product is major product. This is not Hoffman. This is your ZJ product is major product. Major product, and Hoffman is minor. So no need to cram it. You have just to see the reasons. So in this reaction, no need to see the product stability. You have to see the stability of carbanion. This Hoffman is being minor. Till now, if it is clear, let me have a sip of water. Let me check your chats also. If everything is clear, do let me know, my dear friends. Till now, if everything is clear, do let me know. If you got it, show me thumbs up or the hearts. Only some 15 minutes more, I think the whole syllabus will get completed. Baba, kids, Baba has done it or not? Good morning, kids. First of all, do let me know, Baba's hard work is really, oh, Madhuwala is there. Wow. Tattoo is there. Oh, Dhanvant is there. Dhanvant Raj, you are also there once again. Thank you, kids. You are rocking. And in the morning, you have got class 8:30 to 10:30, right? Good morning, Hemant. Darshani, Suhana is there. Good morning. Bardhan. Oh my God. Ashwin is there. Bardhan is there. Chandar, Darshani. Suhana is there. Devant Raj is there. Oh my God, kids. Really, you made my day. Okay. Good morning, Darshani. Good morning. Shweta, Prasad. Good morning. Vardhan. Good morning. Indu is there. Indu, good morning. Indu. Ramesh is there. Oh my God, all my dear students are there now. So now only E1 is left. After E1, I will complete this lecture. Only E1. Let me complete E1, kids, isn't it? Thank you, Shashank, King. Wow, that's really fantastic. Okay, so let me begin with E1 reaction. E2 I have told you, but in E2 reaction, two more examples are there. Let me tell you those two examples also in E2 reaction. So, special case number 2. Special case number 2. Its name is he. What is this? He is Hoffman exhaustive elimination, exhaustive elimination, Hoffman exhaustive elimination. What is required in this Hoffman exhaustive elimination kits? Reactant, your reactant must be quaternary ammonium salt, quaternary ammonium salt with at least 1 beta hydrogen, plus strong base plus heat. This much is required. Whenever you see quaternary ammonium salt as the reactant, strong base plus heat, you have to think about Hoffman exhaustive elimination reaction. Let me give you the best example of Hoffman exhaustive elimination reaction. Let's see to it. Let's see. Best example Baba is going to give you. And the mechanism is same as special case number 1, like special case 1. Let's see to it. This is your nitrogen, this is your methyl kits, this is your methyl kits, this is your methyl. Now see, this is the compound. Nitrogen is having 4 valencies, so plus charge. Oh my god, it's gone. Very bad. Let me write down once again. Special example. Nitrogen plus charge, 1 methyl, another methyl, 1 more methyl, CH, CH2H, CHH, CH3, chloride and Ag2O heat, Ag2O heat. Now see my dear friends, this is quaternary ammonium salt and we can check it that this is alpha carbon, this is alpha carbon, this is alpha, no need alpha, this is beta, this is beta. Here also we have hydrogen, here also we have hydrogen. So the base will come and take this proton, this base will take this proton and you will get negative charge at this place. Base will take this proton and you will get negative charge. This is 1 degree carbonyl and this is 2 degree carbonyl. This is more stable, so more responsible for product formation. Now let's see how the product will get formed. This nitrogen will take electron and it will form 3 degree amine. See, after taking this lone pair, first charge will get away. See what you will get: nitrogen with lone pair CH3, CH3, CH3. It should be like this. Now this carbon got positively charged, negative positive bond, negative positive bond. So 2 types of product, but this will be major because this carbon ion is being more stable. So major product will be CH3, CH2, CH double bond CH2. This is your Hoffman because less substituted, major, and this will be your ZJF. So I have seen the carbon ion stability I've not seen Sedgeff and Hoffman, right? So these are more and less because of their carbon instability, and the mechanism exactly same as that I have told you over there, right, my dear friends? Everyone able to understand? Is everyone able to understand, my dear friends? Do let me know. Everyone do let me know, kids. Is this clear to all of you? Now, let me give one question. The question the examiner can ask you. Let me give you that question, kids. Question. This question has been asked number of times. What should be the product? Now see, you just try in your brain, then I will explain what should be the answer and why it should be the answer. Just try. Now, you must have tried. This is nitrogen positive charge given over there. This is alpha carbon. This is alpha carbon. No need to see. This is alpha. This is beta. Beta is having hydrogen. Fantastic. This is alpha. This is beta. Any side you can see, either this side or that side. Now, I would like to say that base will come over there. Base will take this proton. Once the base has taken proton, this will develop negative charge. Nitrogen will try to take its electron. This will develop positive and positive negative, form a bond, and your product will be like this. So this is being your answer. Everyone got it? This is being your answer. Now, if the examiner want to proceed, want to go more, or want to react more and want to do more reaction with this compound, then what he can do? See, another question. He can give you even tough question like this. This was given like this. You were provided with this product. Now what he will say, do its methylation, methyl chloride. You will get A, then react A with Ag2O and heat. Then you will get B. What is being B? Now see kids, this reaction is Hoffman's methylation that I have told you in the starting. Hoffman's methylation. Application of nucleophilic substitution. This is tertiary, it will become quaternary. Like this. Quaternary ammonium salt. Now that's this. These carbons, there is no beta. Alpha, alpha, alpha. This is alpha, this is beta. Only this one is having hydrogen. Base will come over here and attack. The base will take this proton negative and this nitrogen will take electron positive. So finally you will get this answer. I hope that everyone is able to understand, and to everyone this is being clear. So this is Hoffman's exhaustive elimination. This was the question number 2. And if everyone got it, do let me know in the chat section. Just after this, I'm going to tell you even reaction, and then the whole chapter will get completed, kids. With your hard work, Baba is going to complete this chapter. Really, kids, with your hard work, Baba is going to complete this chapter. Really, really, it's your hard work only. Your hard work only. I would like to say it's only your hard work. Okay. So Baba is going to deal with even reaction. Now, if I talk about even reaction, even reaction will proceed in more than one steps. Oh, ho, ho. One example is left. One example of E2 is left. Sorry, kids. Sorry, kids. One example of E2 is left. The Baba's third example, third special example of E2. Last example, but not the least. When the base is bulky, when the base is too much bulky, kids, too much bulky, like CH3, 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 ONA. Do you know about one singer, Bappi Lahari ji? He was having gold chains. So this case reminds me about chains nature rule. I always call it chains nature rule. According to Baba HSP, this is chains nature rule. Chains nature rule. This is chains nature rule. What is that? If I say, kids, that I am provided with this compound, any alkyl halide, now this is your alpha carbon, this is your beta carbon, this is also beta carbon, this is proton, this is also proton. And if such type of a strong base is coming to approach to snatch this proton, now you can say this hydrogen is sterically hindered. And this is easy to snatch, easily snatch. Now, my dear students, if I say, if somebody is having too many gold chains and having two persons in his life, that one is having gold chain, 1 kg gold chain, and 1 kg gold chain is like so lengthy, when they are going for walk, it's moving like this. And somebody is having 4 kg gold chain, but it's like stick to the neck with dupatta and all those things. Now the chain's nature is going to snatch which chain? The long 1 kg chain, easily they can snatch 1 kg chain, or the 4 kg chain. Which chain can be snatched easily? Definitely the answer is 1 kg chain. If they would have snatched 4 kg chain, then they must be more benefited. But this hydrogen is easily snatched, and this is too much sterically hindered. So definitely for this too much sterically hindered, this will always try to snatch this hydrogen, and Hoffman product is going to be the major product. Hoffman product is going to be the major product, kids. I hope that everyone is able to understand this Hoffman product is going to be the major product. Now, here no need to see the carbon and stability or anything else. Only one thing we require to see, that is too much sterically hindered base. We are going to, let me give you one question based on this. The question which has been asked number of times. Let me give you this question. So, here is CH3, here is bromine. Now, once you are going to do reaction with KOH alcoholic and heat. Next time you are going to react it with CH free, CH free, CH free, ONA heat. Now, in both the type, major product, just see that one major product, this is alpha carbon, this is being beta carbon, this is also beta carbon. So, in that case, definitely this is going to be a major product, because this is ZJ product. But in this case, this is sterically hindered. For this compound, which hydrogen can be easily snatched? This hydrogen or this is sterically hindered. So definitely this hydrogen can be snatched easily, although the product is not stable, but definitely this will be the major product. In that case, that is going to be the major. In this case, this is going to be the major product. Am I right, kids? Am I right? Is everyone able to understand? Before moving towards even reaction, I've told you all the questions. I've given you all the questions along with the best examples. Now, the only case that is left with even reaction, kids, even. ZJ product will be the major product. ZJ will be major product, kids. ZJ will be major product. Will take place in more than one steps. Only 10 to 15 minutes. 10 to 15 minutes. More than one steps will proceed with the formation of carbocation so rate of reaction is directly proportional stability of carbocation now let's see, kids, how the reaction will proceed and what type of product you are going to get. Just see to it, kids. Example number 1. Suppose the reactant is given like this. Now see, this will do solvolysis, this will do solvolysis, and this Br negative due to solvolysis will go like this. This will develop positive charge, and in this way the carbocation will get formed. CH3, CH3, CH positive, CH3. Whenever the carbocation is formed, think about rearrangement. If this hydride is going to shift, get carbocation like this, CH3, CH3, positive, CH2, CH3. So wherever you are getting positive charge, adjacent to that, try to remove hydrogen. This is beta, this is beta. So here you will get two types of product, CH3, CH3, double bond CH, CH3, and this one also CH3, CH3, CH double bond CH2, and here have to remove from here, you have to remove from there, you will get same type of product. So this is major set J product. Now my dear student, everything I have told you, after at the last I am going to give you one table, and that table will include all type of E2 and E1 reaction. So everyone is ready. I will take 10 minutes to give that table. That table is going to play very important role, kids. Is everyone ready for that table? So see that table I am going to give you, kids. Just see to it. Baba is going to give you that table. Just see. If I say type of RX, how many types of RX? One is methyl halide, another one is ethyl halide. In the starting, I have taken only methyl halide, but now I am taking three types of 1 degree alkyl halide: CH3, CH, CH3, CH2X. All three are 1 degree. But what's the difference? This third one I have taken is sterically hindered one slide. This is 1 degree, this is 1 degree, this is sterically hindered 1 degree. Now no question will come out of this. This is also 1 degree. Now 1, 2, 3. Fourth one is CH3, CHX, CH3, 2 degree. Now CH3, CH3, X, 3 degree. Now in the starting I have taken 3 types of patients. Now I have taken 5 types of patients. 1, 2, 3, 4 and 5. Can you see? And in the starting I have taken doctors and head of them. So let's see how many types I am going to take. So one is being head of department is the same thing, ROH or water. If I take water or ROH, this is 1 degree, 1 degree, no reaction, no reaction, no reaction, no reaction. And here 2 degree, SN1, E1, SN1, E1, no problem. This is like earlier only. Now, if I'm taking, kids, see to it. I'm going to take really fantastic one. Just see. If I take CH3O negative, this is strong nucleophile. So it will give SN2, 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 SN2. But here I will not write SN2. According to HSAB rule, it will give SN1. Now, if I take another nucleophile, see, special type of nucleophile, I negative. So I have done one mistake. I have done one, not the mistake. I will not say mistake, but this is sterically hindered. So here E2 will be measured. That is the most important thing. It has been asked once in AIMS. 40% SN2, 60% E2. This question already has been asked in your AIMS examinations. Let me underline it. This is very important question. Very important. Here, Now kids, I negative or RS negative. Why I am saying that? This was, oxygen was the donor, strong nucleophile, it was strong nucleophile as well as strong base also, strong base also. So it has done E2 also. But if I talk about I negative, RS negative, they are only strong nucleophile. They cannot behave as base because on moving down the group, the nucleophilicity will increase. Strong nucleophile. So they will do SN2, 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 and here also SN2 kids. And this I have written HSAB rule. So HSAB rule, it should be mainly E2. But here it HSAB rule is applicable, so mainly SN1 according to HSAB rule. Now here no HSAB rule is applicable, no HSAB rule is applicable, but there HSAB rule. But you must be asking, sir, what is HSAB rule? Not required, not in your syllabus. Now last but not the least, too much sterically hindered base. Too much sterically hindered base. Now in this is least sterically hindered, so it will give SN2. But rest of it will give SN2 and E2, and rest of other cases it will just give E2 because it is too much sterically hindered base. So everywhere it will give E2. This is the memory chart. Whatever the question they are going to ask, you can answer from this memory chart. I think this is clearly visible to all of you. Kids, do let me know it is clearly visible. If you are not able to understand, write down in the chat section. Let me check it out. Chat section. Thank you. Thank you. Praveen. Sam. Thank you. Kids, do let me know it is clear to all of you. Everyone can see it very clearly. All concepts clear. Now let me know in the chat section. Just see your NCERT. Just check your NCERT. Each and everything Baba has covered or not. Is anything left, kids? Baba has gone through each and everything concept, kids. In the starting, it was looking that number of hurdles were there, number of obstacles. But once if you think you are able to do that, just try to resolve it. Once if you think you are all able, then you are almost to be able. And to decide to decide upon achievement is the achievement itself. Once there is a will, there is a way is an old saying, but it is still true. So in the starting, number of hurdles were there. But yes, with the hard work, all the obstacles, they have gone down, and the means to its achievement has appeared in front of your eyes, in front of my eyes. But yeah, in the starting, you have seen, kids. Really, I would like to say thanks from the inner core of my heart that you were also consistent in the starting. See, the audio problem was there too much. This was the first time happened with me. But yeah, kids, you have really true students. I would like to say you're true students, that you were there at that time also. And thanks a lot. Thanks a lot. Bye to all of you, kids. God bless you. Love you, kids. Love you. Good morning. What to say? Good morning, good night, and all my dear students. Really, thanks for being with me, for always being with the true heart persons. And once you are going to become doctor, engineer, then definitely you are going to help number of people, crores, millions of people. You are really going to help the society. So bye to all of you kids. Bye bye. Bye bye.